So David, we're live now?
Yes.
Recording, okay. So good morning everyone, or good afternoon if you're in other parts of the world. Thank you very much for joining us today for the Quant Surveying International Development in BIM Presentations CPD Event. I'm delighted to sort of open today. My name is Dr. Paul Hampton. I am the QSI Global President, and with me I'll give you an introduction to Quant Surveying International is Suzanne Miller, who is the Global Business Manager. We've got representatives from the University of Wolverhampton and Ramboll who are our guest speakers today. Can I thank Dr. David Heason and Dr. Moses for joining us and presenting as well today, and Dr. Mnagwan as well, who will be saying a few words about Stellar Group. So predominantly, as you're aware, this will go out to 30 plus countries. Some will be viewing later. I know some of you are picking this up live, so thank you very much for joining us. Wherever you are, I hope you're keeping well and safe at this time. And we hope to be back with you over in your own country and overseas in the near future, and presenting direct from your country, your designated country. All the very best as well, and welcome to global board members and also national board members who may be joining us on this presentation. So without further ado, thank you very much for joining us, and I'll hand over to Suzanne Miller, who Global Business Manager, who will be telling you a little bit more about QSI. Thank you.
Good morning or afternoon to everyone. Thank you for joining us today. And I'm just very quickly, before we start, going to say thank you to our presenters that you'll be hearing later on. Thank you all, guys, very much. This is an event, Quantity Surveyors International, in conjunction with the University of Wolverhampton. So thank you also to the University for allowing us to be here today. I'm just very quickly going to tell you a little bit about Quantity Surveyors International. I know many of you know of us, but I also know there's quite a few that don't really. So we are a professional body for all those involved in the financial aspects of the built environment across construction and engineering. We were founded in 2004, so we're sort of coming up towards our 20th anniversary, but we are still, in the global scheme of things, a very young organisation. When you look at organisations like the CIOB, the RICS, we're way off the hundreds of years that they've been going. We're much smaller as well because of that, but we think that allows us to be sort of dynamic and flexible and easy to change to what's happening out there in the world. We are right across the globe. We have, in fact that's the next slide, there we go. We have members in over 50 countries. We have national boards in some countries, one obviously here, our UK and Ireland board. We have one in Qatar. I have to say not very active at the moment because everybody out there is absolutely up to their eyes with getting ready for the World Cup, so they've just not had time to think about QSI. We also have a board in Hong Kong. Likewise, they've all been swamped by the pandemic, so there's been no meetings out there. And Sri Lanka, we were due to relaunch, and they, of course, also have gone into crisis. So we've been a little quiet, but we're out there and all ready to go when things improve. So what is QSI? Basically, we are about promoting standards within our industry. That's our main thrust, really. And we do that in a number of ways, which I shall come on to shortly, so we'll move on. Professional development through CPD and events like this. We have a research department, which I think some people here are part of. We have a professional magazine which goes out every quarter, which obviously keeps people up to date with what Quantity Surveying is doing, Quantity Surveying International, but we also include several articles which we hope you will find of interest about developments within our industry, contracts, that sort of thing. What membership does give you is professional status. So if you're a member, you become an MQSI, you have those initials after your name. We're also very much about working in collaboration with other organisations, so we don't believe that all these similar organisations should be working in isolation and sort of fighting against each other. We have collaborations with the CIOB, the RICS. I know Dr. Paul at the moment is talking to CABE about working with them, and also organisations across the globe. We work with the Quantity Surveyors Association in New Zealand and other places. I'm going to skip that one because Nagwan is going to talk to us about that. So our forthcoming events, well, we're right there on the first one already. We have a couple of webinars coming up. We have what we call a First Thursday Club, which, as it says, first Thursday of each month we have a webinar. It's always from 8 till 9 in the morning, which means you can come and attend our webinar. They're free of charge, and then you can go on and get on with your day's work. So they're the two that we have coming up at the moment. Just email me if you want more information. So that's just an overview of what I've been talking about, really. We'll skip through that. So we have student membership, which is free of charge. So again, just email me if you'd like to join us. And then we have associate members, full members and fellow members. And again, if you're a fellow, for example, you get to have FQSI after your name. So that looks like that's the end of my presentation. I hope that's been helpful and you know a little more about us. Thank you very much. So, are you coming to do the
Yes,
honours now?
thank you very much indeed, Suzanne. Delighted to give us an overview of QSI. I know there are members and non-members in the room and online, so if you do really want to get in touch with Suzanne, the professional body is a non-profit making organisation, so we're not there to make lots of money, we're there to sort of disseminate knowledge exchange, knowledge transfer and support people into the sector. So please do get in touch with Suzanne. As part of sort of our work we've done with sort of growth and future-proofing as well, we've also developed a Stellar Group, and here to tell us all about the Stellar Group is the first Stellar Group chair, and that's Nagwan. So Nagwan, if you want to come to the lectern and tell us a little bit about Stellar Group, that would be amazing.
Thank you, Doctor. I was going to be surprised really if I'm not going to give an introduction before I jump into the presentation. So, good morning everyone, and my name is Nagwan and I'm an apprenticeship learning and skills coach. My job is supporting the apprentices to enhance their knowledge, skills and behavior, and because I come from the same background they are studying, which is architecture and built environment, so I know exactly how to search and find the activities to support the students. What we are trying to do nowadays, and this is one of the events, is to create something was based on your surveys. I'm not sure if the ones online are my students or skills coaches students, but all I want to say is that there are going to be more and more events coming through, so majority are going to be here on campus, so we'd love to see you here, please, and we'll try to make it online just in case if you cannot come in, because we do understand you're all working, so it might be a little bit hard to come here. What we're trying to do is to, just as you can see on the slides, support continuing professional development. You could be an apprentice, you could be a QSI member, or any student on a traditional route. Please feel free, as Suzanne said, to join, be a member. All the students are free of charge, so make use of it. If I'm in your place, I would do it definitely. And hopefully when you finish your degree or your chartership at the end, holding your chartership, you can have the member of being either a fellow or a full membership, which is MQSI. I will leave you today with for our first speaker, Dr. Moses. So he's gonna speak about the introduction of BIM and give you a little bit hint, because this is going to be a series of the BIM to understand how to use it in your workplace. So we are going to just give you an introduction, what's going in in the business or the workplace. We have Dr. David Heason is going to go speak about digital construction, and we have ramble here with speakers who I'm going to leave it to them. They can introduce themselves at that time, where they are going to show you real case studies. And then we are going to get this into series. So please keep in touch. Look at the CPD emails we send them across, because you might be targeted to listen to what's specific to your course. Might be building surveying, quantity surveying, architecture, and so on, whatever the courses we do provide. So let me introduce Dr. Moses. And do you want to say something? Okay.
Thank you.
Do you need to connect it with it, right?
Yeah, no. Thank you.
Okay.
Yeah. Okay. Thank you, everyone. Thank you, Dr. Paul. Thank you, Dr. David. Thank you, Susanna, and Magwan. It's a privilege and an opportunity to present to you, to QSI, an overview of BIM and what is going on in terms of how the standards and processes have been set to ensure that digital processes are embedded in construction projects in the UK and also globally as well. My name is Dr. Moses, or Tuchku Moses, you can call me Moses, and then I'm a senior lecturer in quantity surveying and a program lead for construction management as well. So we're going to look at overview of BIM. In other words, just an introduction, an overview of BIM. Then my colleague will come and look at the technological applications within that is being used in building information modeling. So we're going to look at what BIM is. Just not going to go too deep around BIM applications, but I'm just going to give an overview of what BIM is all about. Talk about standards, talk about guiding principles, talk about terminologies, because there are lots of terminologies used today, in the BIM world, that could bring confusion if you're not very familiar with that environment. So I'm also going to look at global adoption, BIM global adoption, and case studies. So we're going to look at some videos, just running through few case study projects, so you can also see where BIM is applied before Dr. Hisam will come to look at, show you some digital technological applications with regards to building information modeling. Okay, so these are the things we need to look at in this first section. So BIM definition, what is BIM? Because a lot of people don't really, or there are varying definitions of BIM, and I know different organizations, different countries kind of like come up with their own definition of what BIM is because of what they think it means to them or how it could be applied, to enhance or to improve the existing processes. So that's why UK has definitions, US has definitions, Finland has definitions, different countries with different definitions. However, I think this particular definition is a bit central. and is centric to digital application, in my understanding. So it's been what has been a collaborative way of working, which is underpinned by digital technologies. It's a collaborative way. We're going to talk about collaboration later on, but it's a collaborative way of working which is underpinned by digital technologies. And it uses a shared digital representation of an asset to facilitate design, facilitate construction, facilitate operation processes, and to support making informed decisions during construction projects. It's applicable to different projects anyway, not just only centric to construction projects. But it uses a shared digital representation. In other words, it uses both digital representation of physical and functional characteristics, right? So it shares that digital representation of an asset to facilitate or to enhance design processes, construction, operation processes, and to form a reliable basis for decisions. So greater efficiency can be realized due to significant pre-planning activities during design and construction phases, and that provides very comprehensive information at handover. If you look at what I put on there, so you can see it enhances, it covers design there, covers construction, covers operation of that asset, covers decommissioning. That is what they now call deconstruction or demolition of that particular asset. Where we are, I was in presentation, was it yesterday or 2 days ago? I can't remember now. Jonathan did a presentation of this whole state of the art building that we're in at the moment, and later on I was able to catch up with him to ask him a few questions in terms of the BIM processes they deployed to construct, to design and construct this place. And I did ask him, so the university has an asset model? He said yes. Okay, so you can see that in terms of operation of this particular facility, that asset model that the university has would help the university manage this more efficiently, rather than doing a reactive, a maintenance is going to be very proactive, or predictive maintenance, as the case may be. Okay, so this is what BIM is all about in terms of, a very generic definition of BIM. Right? It could be tailored depending on culture and region and what is obtainable in different places. However, BIM centrally is a collaborative way of working, which is underpinned by digital technologies. Okay. So there are standards in BIM as well. BIM, a lot of people think BIM is technology. You ask people, say, oh, we're doing BIM. What are you doing? We're designing in 3D. And they think that is BIM. That is completely different from BIM. What makes BIM, what makes Building Information Modeling what it is that it does provide platform where standards, protocols, processes could be utilized. That's the key thing that informs Building Information Modeling. While the technological tools are kind of like enablers, although software is used to design, software is used to monitor, and control projects, software is used to enhance productivity, on site while the construction is going on. They're all enablers. But the key thing that underpins Building Information Modeling is the processes, which the core of those processes is the standards, right? So if we look at the standards now, pre-2010, there is BS 1192, right, standard, which deals with, collaboration between, amongst the AEC professions, right? That is the architecture, engineering, and construction professions. So pre-2010, there is BS 1192 2007 that was there to enhance that collaboration there. And then after 2010, going into 2011, between 2011 and 2012, right? And then the government came up with construction strategy, which you can always find online to read to enhance your understanding of government construction strategy. Then going into 2012, 2013, there was formation of, being task group, and then they came up with PAS 1192, part 2 there. And of course, a lot of papers on building strategy and how to go about things began to come up. And the reason for this, standards 1192 PAS, 1192 PAS, part 2, part 3, part 4, part 5 is to enable BIM level 2 deployment in the industry, right? Because before that time, works were done in silos. What that means is that, the industry was so fragmented, people were producing things differently and then coming together to discuss, what they wanted to achieve. But that wasn't working, because by the time they produce things in silos and then come together to look at it, they found out that correction will take a lot of time, and there's going to be a lot of waste of efforts and duplication of works. So between 2013, 2014, 15, then they came up with lots of standards there, which is 1192 part 2, 1192 part 3, 1192, part 5, and then going up to 2016 and 17, 1192 part 6 also came up. Alongside, they were also producing other, BS standards like 8536 part 1 and 8536 part 2. And then after 2017, 2018 into 19, of course, there were a lot of trial projects to ensure that those processes work. Those standards, rather, to ensure those standards are working. And then there were a lot of feedback, because it's open to industry-wide consultation as well, to feedback on what is working and what is not working. So they feedback, in terms of the gaps that they've identified and the things that are very efficient within, those standards. And of course, that necessitated an update on that. And of course, they also wanted to adopt that standard, beyond the United Kingdom, and other countries wanted to adopt it. And because of that, they also came up with now a standard that could be internationally recognized and implemented, which they now came up with what is called BS ISO 19650. Okay, they came up with that, and then they produced part 1, part 2, and then a guide to how to use those standards. So these standards are the underpinning elements, or underpinning things that governs the implementation of BIM, or that enhances outputs of different phases in construction projects or other projects as applicable. And of course, this part 1 of 19650 ISO is, it's the national forward. Part 2 is is a standard plus the national forward. Then part 2 is an extension of PAS 1192 part 2 into ISO, which is also has national annex in it. And then 19650 part 0 is guide to BS ISO 19650. So these are the standards that that they use at the moment, not just only in the UK, just like I said. It also extends to other countries that are using this, and because of that, some UK-centric terminologies have been updated to accommodate other users in other countries, around the globe. Things like exchange, employers information requirement, which is called EIR, for example. We're going to talk about it a little bit later. It's now called exchange information requirement. Okay, contracts are changed to appointments. So there are different terminology, there are different changes in terms of terminologies to accommodate users in other countries. So like I said, BS ISO 19650 Part 1 covers concepts and principles. Part 2 covers delivery phase of assets, and Part 3 is just a guide on the transition. Okay, so if you look at this standard I put here, you find out that BS 1192 and past 1192 documents were transited into international standards, which are these standards that I've outlined here. Okay, which are those standards I've outlined there. And like I did mention, part 1 there is dealing with concepts and principles, and part 2 is dealing with delivery phase of the assets, and then that is guide to the transition. But there are not so much changes, and the things that are used nationally in the UK is still annexed within this standards. So again, at the moment, you now find this standard, the ISO international standards, in collaboration with some of the existing UK standards, though a lot of them are still undergoing updates, and then they would eventually become, ISO standards, like past 1192, part 5 that deals with the security of, asset information. That is eventually going to become, ISO standards. So they're still transitioning these standards to ensure that other users from other countries benefit from the wider use of these standards towards being implementation. Okay, so another thing I also want to just touch on is the BIM protocol. Okay, so beside the standards, there's a protocol that supports that those implementations, and that was published. The first one was published in 2013, another one was published in 2018. Okay, and it's commissioned as part of construction CIC, that's Construction Industry Council's response to the UK government construction strategy. The purpose basically is to maximize production efficiency through adopting coordinated and consistent approach to working with them. So it's just to maximize production efficiency through adoption and coordination, and then to have consistent approach to working with BIM. And this is essential for ensuring that these two BIM files are structured correctly, and that defines the standards and best practice, right? So that people don't just come and bring things that they want to bring. There's a protocol that's being used to develop to ensure that the files are structured correctly, and then when it's being used, you now know that it could be used by any party, any member of the project. For example, I was with one of the key professionals in HS2 at some time ago, and he said that they have a very strict protocol, very strict standards in terms of protocols and what is called common data environment that they use to implement, they use to develop and to name their files. So it does ensure that files are structured correctly, and they define the standards and best practice. And then including it does include contractual information exchange requirement as well, which is set out, in this BIM protocol alongside wider project deliveries, which is established by the contract. Okay, so BIM protocol also supports, and if you look at a typical BIM protocol document, you find things like details of BIM information manager and BIM coordinator. You find things like sections dealing with common environment, sections dealing with BIM execution, plans, sections dealing with levels of model details, that is, level of details as designs progress. Things like project information model, PIM, and things like asset information model, things like model production and delivery table, MPDT. You find all those within the protocol document, and this protocol document is actually very supportive to helping in developing information around BIM implementation, developing information that will support in the design and construction, operation and management of that asset, and also ensure that collaboration works very seamless amongst project multidisciplinary project parties, if you like. So there are guiding principles as well of BIM. There are guiding principles of BIM, just like or you may want to know that BIM is about to enhancement or improvement of information management, basically. So it's centric around data management of construction information, right? So the guiding principles, of course, when you want to deal with BIM, is talking about people, processes, and technology. You have people who understands the processes, and they also implement the technology, which are the enabling tools that's being used. And this guiding principle deals with how information should be designed, how construction should be built, and how it should be operated to realize the best value, or to realize the best benefit that could come out of a construction process or a construction project, or benefits that could come from this new way of working. So underneath that, you find people, you find processes, you find technology. Processes, part of that processes is the standards that I've talked about, all the standards that started pre-2010 into 2020, where past documents are transited to ISO documents, and then the BIM protocol that also ensures maximum use, maximum and best way of designing things, and how to improve processes going forward. Then there is collaborative engagement as well, which is part of the guiding principles. If you look at this, you see BIM is not just about technology, it's a new way of designing, constructing, and managing assets that's enabled, or that enables the use of technology. Okay? And fundamentally vital than technology is a set of processes that should be followed, right? Which is outlined within the ISO 19650 and BS, or past documents, if you like, series of standards. And then the way it changes the working practices at an operations level. For example, I've mentioned this particular building and the university as the client having the asset model to be able to maximize or to enhance the operation and maintenance of this particular facility. Right. So it's very important that there is collaborative engagement that would support to improve the workflow in the industry and how things are being done at the moment. Okay, and when we talk about collaborative engagement again, you find where that's open sharing of information, open exchange of information, sharing of experiences among the supply chain in a construction project, right? So that collaboration there is one of the key aspects of being implementation. It encourages them to find ways to resolve issues before it becomes an issue on site. So you can literally resolve things virtually before you get into executing that on a physical site. So again, another guiding principle there is that you start with the end in mind. You start with the end in mind. So clients would always need to define what they want to achieve from the very outset. What is it they want to achieve from the very outset of the project? That would really then guide what requirements, in terms of what is set in a document called EIR, that is in ISO terminology now, exchange information requirement. That will really help to set the requirements and what every professional involved in that project should be working towards. So one of the guiding principles of BIM implementation is that the clients that wants to implement BIM would have to start with the end in mind. And then digital assets is also another thing there, and this means that in the end, at the handover, the client must have an asset, because at the outset of that project there would have been what is called asset information requirement documentation, and again there would have been organizational information requirement that sets out the strategic objectives of that organization with respect to what they want to get in the end of that project and how they want, the level of the degree of efficiency they want to achieve, in terms of the management and operation of that particular asset. So digital asset is also another thing that should be there as one of the key guiding principles, of BIM implementation. Okay. Again, finally, holistic approach to security. It's also another thing. When all those information is being produced, how do you secure those information? Because of course there are threats, there are issues around, individuals that's not supposed to have access to this information. Having access to this information, how do you protect and make sure that information, whatever is being stored in any repository is, safe in that place? Which is why there is PAS 1192 Part 5 document that is, of course, are transiting that, if not transited already, into BS ISO 19650 document. Okay. So a key problem that is addressed by using BIM is the issue of rushed decisions being made with insufficient and/or incorrect information. Okay. So like I said, starting with the end in mind, these decisions are pushed upstream so that they are better informed and do not present themselves unexpectedly. So then going over to then BIM terminology. We've looked at what BIM definition is. We've looked at the standards that are there. We've looked at the guiding principles. So let's look at, like I said, I'm just providing a basic, overview, knowledge and understanding of what BIM is all about. Okay, and before I forget, there are also levels in BIM where you have level 1, level 0, level 1, level 2, and then into level 3, and level 0 is just the normal traditional process where things are being designed, using drafting skills and all that, using hand drawings, okay, majorly drawings, and then cost information is being extracted using scale rules, traditional process of measurement, and then the plan of that project or the program that will deliver that project is also done very traditionally. And then you come to, there's no standard anywhere there, and then you come to level 1 where you have some elements of, there's a 2D design there into some 3D CAD design as well to show the geometry or the graphical information of a particular project. But there's not much of guiding principle around that as well. But then when you come into, and things are also done in silos, right, which also is part of what is fueling the fragmentation within the industry at the moment. And then into level 2, where you then see collaboration there. You have different data sets for different professions, like you have architectural information model, you have structural information model, we've got building services information model, in terms of mechanical and electrical. So you have different data sets that's being designed differently and then federated to ensure there's no conflict or there are no clashes, rather, to ensure there are no clashes in those produced information. Of course, definitely there would always be clashes at different points, and those are resolved, and that is what is called being coordination. One of the projects I was part of, a university project, that is the business school just across the road there, close to Wave Stadium. We were doing beam coordination as that building was going on, and that beam coordination was just detecting different clashes at different levels, and all the consultants were in the room and they were resolving it, hands-on as we were, doing that beam coordination there. So that's what beam level 2 does. It's underpinned by the standards that I mentioned earlier on, and of course the key thing there is collaboration amongst the supply chain. So that's how real work is being reduced, risks are being reduced, and cost is being minimized, and all that. Okay. And then some terminologies, you find things like employers information requirement. I didn't mention this is UK terminology, but in terms of internationalization of this particular of standards is now called exchange information requirement. Okay, so that defines this particular EIR. You would have heard, if you've been in different meetings or projects, of course, that try to implement, even if it's not holistic implementation of BIM, try to implement elements of BIM. You will hear things like EIR, which is employers or exchange information requirement. So this is where employers requirement is clearly defined. Okay, so it defines which models need to be produced at which project stage, right, together with the required level of detail and definition. Okay, and these are key deliverables in the data drops contributing to effective decision making at key stages of the project. And that also incorporates, that is incorporated into tender documentation to enable suppliers to produce their initial BIM execution plan, which we're also going to talk about, right? So there are things like organization information requirement there, like I mentioned, and then asset information requirement, and then employers information requirement. For example, Department for Transport, let's say, right, they are the owners of HS2 project, for example, and then you find organization like HS2, which are their delivery partner. Okay, so DFT would have given HS2 they would have had an enhanced or very detailed discussion, conversation around what their strategic objectives are, what they're looking to achieve in HS2 with respect to design phase, construction, particularly operation and maintenance, because after handover they are going to undertake the operation and maintenance of the particular facility. So based on the OIR, right, then they would then come up with asset information requirement, which is the AIR, and then that would then inform, that would also inform employers information requirements. So based on the EIR, the contractors would then know what they respond with, which they respond with what is called, BIM or Building Information Modeling Execution Plan, which is called BEP. So for employers information requirement, what is to be produced at each project stage, to the required level of detail or definition, the deliverables in terms of data drops are very clear, and of course that helps with effective decision making at key stages of that project. Okay, and again EIR is incorporated into tender documents, and then bidders submit approach to project information management, and clients also evaluate proposed approach capabilities and abilities of those contractors, okay, in line with what is within the EIR. So what part of the EIR document will cover areas like technical details in terms of software platforms, definitions of levels of detail, management in terms of details of management processes to be adopted in connection with that building information modeling project, and then the commercial in terms of BIM model deliverables, timing of data drops and definitions of information purposes as well. So it will deal with the technical requirements there, in terms of coordination, in terms of data exchange formats, in terms of level of detail, and all the training needs that will be required there. Then they will also cover management sections and also commercial sections. This documentation is actually what informs who is eligible or who has the competencies or capabilities or the required skills to deliver that particular project. Okay, so when they design the what's it called now? When they design the questionnaire, it's just keeping my mind. When they design the criteria anyway, that informs them to know who has the capacity or who has the competency level to deliver those projects. Okay, that is informed from EIR. So EIR is what they use to design those questionnaires to send out before they can actually know who is eligible to tender for those projects. Okay, or who is not able to tender for those projects. Then coming to because of our time, coming to BIM execution plan as well. Okay, once the EIR has been clearly defined there, once the EIR is clearly defined and is tailored to be project specific, this document is not a generic document. It has to be very project specific so that the contractors will know what to respond to. Okay, it's PQQ I was thinking about, pre-qualification, questionnaire that actually knows who has the competency. So when they disseminate the PQQ, they can tell, when they get the responses back, they can tell, okay, this one's within our, a selection list to be invited for tender, depending on the type of tender that's being used, right? These ones, okay, can be invited. Let's see how they can deliver. And then there are, of course, part of the tender documents that's been given to them is employers information requirement, and based on that they will respond, again, depending on the procurement that has been, agreed and the contractual arrangements, they then respond to the BIM execution plan. And then after that, they now decide, when they've evaluated all the tenders and all that, based on the competencies required, looking, considering that this project is a BIM project, they can then know who, they can award that contract to. And then from there, they can then, begin to produce, the contract will begin to produce, other documentations like, master information delivery plan and task information delivery plan, and so on and so forth. Okay, so the purpose of BEP is to facilitate the management of information on the project. Okay, and that includes the contractual information exchange requirements that are set out in BIM protocol alongside, the wider project deliverables as established by the contract. Okay, and then BEP, like I mentioned, is prepared by the suppliers who will supply those, services, who will supply, those products to the client, and that explains how the information modeling aspect of a project will be carried out. Okay, and BIM execution plan acts as a digital method statement, just like on a traditional project they will always submit method statement. So BEP or BEP acts as a digital method statement setting out the supply chain's agreed approach to BIM implementation on that project. And there are pre-contract BEP and there are post-contract BEP, right? So, and pre-contract, of course, will cover project information planning, cover goals for collaboration, cover project milestones and project information management delivery strategies. And then post-contract BEP deals with management aspect, planning and documentation, standard methods, IT solutions, and all the delivery plans in terms of specific tasks. And again, another terminology you find in BIM beside EIR, OIR, AIR would be common data environment. This is very key to collaboration. It's a single source of information for any project that is used to collect information, share information, manage information, disseminate that information, and those information that will be shared, disseminated, must be approved files, and then that could be shared amongst multidisciplinary project team. And then CDE may use a project server, it may use an extranet, it might be a file-based retrieval system or other suitable tool sets. Most commonly used is they use a project server, or they can use a cloud-based system where they dump. For example, there's one BIM Extra. It's a common data environment that is in terms of the software tool. For project is also a common data tool as well. So in most cases they try to dump things in the cloud, dump information in the cloud, and every user or key members of the project team that requires access would always have access with their login detail to that platform to integrate, produce information. Okay, so I just want to show you BIM global adoption and few case studies. Let's hope I'm able to pick this up. Okay, so I just want to quickly run through this because it's quite much, but I want to quickly run through it. If you look, you would see, kind of like a global map, showing where one sec. Global map showing where things, are at and how far BIM is been implemented, the extent of implementation of BIM. BIM has been implemented in the United States, and then you can see the use of CAD, there, and also the use of BIM, and you can see, levels of implementation there. If you go on, you also see this is United Kingdom, like I presented to you, when those standards started coming up, and when government construction strategy came on board 2011, before standards started coming to find a way to implement BIM, right? And then in the United Kingdom, they just wanted to develop a 4-year strategy at the time, which of course has been implemented now, and this is just to ensure that there's a change in the dynamics and the behavior of the construction supply chain. And I think that has been achieved. If you look at the National BIM report of last year, you would see that things have advanced considerably. Okay. And then it's being adopted in Finland, and it's quite advanced in Finland as well. And part of the software tool that's been supporting that also, it's Tekla. Tekla is being used to design and structural elements or structural components of that. For example, if I don't know if this can play. So you can see that was the Qatar National Museum, and if you look at that, you would find that rather than imagining elements and components, they can actually visualize, including the piles, that's underneath the foundation of that museum, and they can visualize everything they're doing, and they can interrogate this model, right, element by element, and just to be sure that everything is correct and accurate before things goes up to site physically. Okay. And then you see Germany as well. It's also been implemented in Germany. Just want to show you how things it's been implemented across the globe. And then in India as well, but I just want to play a particular video for you as quick as possible, and then another 2 videos, and we're done with this section today. I know some of you might be going to Qatar for the World Cup in November. So most of those stadiums are BIM projects. Okay, they're all modeled with BIM processes, and they're all simulated, and everything is run just to be sure that everything was fine before they deployed the solutions to physical sites. Just want to play a few of those stadiums for you. So that's just to show you, one second, I need to return back to my slide. So they were able to, visualize, design everything they needed in a virtual environment, visualize that, run their simulations. You can see to the detail, even to the landscaping, even to the cheering of, the spectators in the stadium, right? I don't want to finish that video because of our time. So you can see what BIM is doing, globally, all around the world. I have two more, case studies just to, if you just bear with me, we'll be down just very shortly. This is a project that is done in the UK here. Then another one after this is a project that is done in Alaska in the US. So you can see how they implemented BIM, actually full BIM level 2 implementation they did, and this is a project in Cambridge, right? Cambridge down, at Cambridge town there. So Cambridge University rather. So you see what they did respect to this project. So that's just one of those.
A new way of driving needs a new way of thinking. It's time for car insurance with added charging perks, so you can get cheaper access to public charging and money off home charging devices. Electric made easy. Direct line. We're on it.
Hella is a £79 million research laboratory development for University of Cambridge. They wanted a fast track build. They had a specific criteria financially. As a result of that, we looked at some really fast track methods of construction, precast frame, precast facade panels, those elements all together, really trying to reduce that on-site period and overlap it as much as possible with the design period.
What they've done is designed it so that the facade, the window panel can be all sort of manufactured off-site, bought site, craned in.
The client initial expectations being the 5 years, 60-month period, whereas we're looking to complete it in 42 months. We were given the project as a greenfield site, so originally it was a cricket field for the university. So we initially did a site strip, just clearing the grass away from the surface of the ground, and then installed hoarding, and then we started to construct the basement. So that involved installation of sheet piles around the perimeter of the building. We then dug out to a base level and installed some props horizontally across the basement. And then following that was the construction of an inner layer of precast. We then followed up with columns and the ground floor slab, which are delta beams and precast hollow core planks. This carried on through the rest of the levels, with the cores being installed first, then columns, precast pitch beams and precast hollow core planks, then following for the remaining levels up to the roof. When we finished the frame elements, we then installed the perimeter envelope. This was installed in 4 or 5 weeks, so a very, very quick period of time, wrapping around the building from level 2 up to the roof level. Following completion of the precast envelope panels, the steel frame to the roof was installed, and that's the completion of the frame elements. We have our internal gateway process to decide whether a project is suitable for BIM, and it's by default it will be BIM unless there's a number of reasons that mitigate and where we can't implement.
It's a very large project. There's a lot of financial implications of the project. It was deemed that this one should be one of the candidates for getting the processes in place, and we've been on a steady path ever since. So this has been a trailblazer in a way. For setting up our own BIM protocols and how they might work.
So there's a 2-stage design and build, but actually contractor is on board right from the concept design, so REBA 1,
we already had our design team. We were able to sit down with them and effectively do a bit of a kick-off meeting.
We had a start of an EIR. The university deployed some consultants, as most people do, to come in and talk us through the process.
Honestly, when I first picked it up, it was about that thick, and it wasn't project specific. But the nice thing with Cambridge University, they are really open to engaging with the supply chain and start to, finesse that document to something that can be delivered against.
We did a lot of reverse engineering, taking what we had, going back to the Kia and their supply chain, said, okay, what's your bet? Let's have a look at your bet. What were the questions that your the execution plan was answering? We're getting to the point where not only does it satisfy what the university wants, it allows the supply chain to actually deliver it.
BIM Extra was our common data environment for the project. BIM Extra essentially is a relational database where we can bring the models, the geometry, share information, and actually deliver the data side, the non-graphical information side of the project deliverables. The way that works, we set up fortnightly model information exchanges where each consultant, subcontractor or task teams has terminology, input their model geometry and data to the system. That's then available to anyone on the project set up on the system and allows people to only effectively access the latest information. So there is that revision history there, but it's the most up-to-date information that everyone's looking at. You wouldn't want to federate all the models together at any one time, but you sort of pick and choose what you want to look at that point in time. So certainly for the BIM workshops, the fortnightly coordination workshops we carry out, we'll set the agenda, we'll see what services we want to look at, what parts of the building, and then federate as required.
You had to sort of think quite a lot about how, say, a detail was going to work. You had to sort of think about that whole situation a lot early on. It made you think about how is this going to be built, how's it going to be phased, how's it going to be brought to site, and it sort of created lots of questions for you to answer quite at an early stage, which is quite good because you don't then go down the design process and find there's a big significant problem.
Designing, everyone is working in Revit. That's not something we've specified by any means. Honestly, it does make interoperability easier. So yes, we have 4 subcontract trades currently working, as well collaborating into the projects using Revit, albeit using a number of plugins to get those fabrication parts delivered in the models.
As with all research facilities, lab facilities, this building is heavily serviced with M&E components. The design analysis for energy and obviously BREEAM requirements was carried out in the BIM environment using the Revit model that was exported to IES software.
We were absolutely convinced that we needed to get the subcontractor on board early to work with the consultant. So we got SES on board at the start of REBA 3 to sit and work with Arab, access to the models, to the drawings, obviously the common data environment, to work with them to create a buildable design.
The M&E subcontractor came on board and took control of our model and started to develop it further for installation purposes.
That coordination of the design to enable us to start on site was really helped an awful lot by BIM. The coordination between the precast and the MEP is very, very important in order to get the MEP integrated within the precast frame, which has to be fixed at an early stage.
We were able to not only discuss drawing outputs with them, but actually get in there and open up the models so they could appreciate the 3D space effectively.
There's an immediacy to it, you're quite close to the process, things can be looked at and altered or suggestions taken on board much more quickly than they could be in a conventional setup. It makes the end user very, very close to it. And once they start talking about where they're sitting, you've kind of got past some of those earlier design issues that you can come across in these sort of projects.
And we've developed a detailed 4D model, specifically for the frame, with each individual element being modelled and a program associated with that. So we can look every week at each individual item of the frame that's being installed, and the guys really have a good perception of what's actually going to happen. I think often we use markups on layouts and things like that, which work relatively well floor by floor, but when you've got multiple levels being constructed over a week because of the speed of the frame construction, I think the 4D's really helped with that, and the guys being able to understand what's happening.
We used BIM Extra and we used Insight, both of which are very good tools for what we were doing. It enabled us to not create just a one-off 4D simulation, but an ongoing progressive simulation that we could use for comparisons between actual and planned. The automatic coding link between the model and the program is basically one click of a button. Traditionally, you don't have the ability to visualize a program. You see bars, and coming from a BIM perspective, I don't understand the bars. I understand the model, and everybody else understands the model because you can visually see the 3D representation.
I think the interface with the client and other stakeholders has been very important as well. We're quite close to another lab facility, and the 4D models and videos are very helpful in order to let them know what happens.
Okay, if I stop that one there, you find that in this particular project, right, it was £79 million project, and it was initially, agreed program to be delivered in 60 months, but it was because of being enabled process, that they deployed on that particular project, they finished it in 42 months. So imagine, the cost savings, imagine the time, the cost savings that they would have, achieved for that 18 months that they saved in that particular project. So those are the kind of things, and in this particular project, it was a full level 2 BIM implementation. They started with 3D, model, and they used, 4D, from that 3D, they were able to extract, time-related information to plan their program, and they also, extracted cost information from that, and then also they handed over asset model to Cambridge University, as the asset that could support them to operate and maintain and manage that particular facility going forward. And the key thing is that the lessons learned, because they were to do another project of over £300 million, and the lessons learned, they were able to outline those lessons learned, and then they transferred that to the next project they wanted to do. So this is the last case that I want to show you, Alaska project that was done in the US. The key thing is that because they spent a lot of money operating and maintaining their facility, they wanted being implemented, and they wanted a good organization, a good contractor that could implement BIM in that project, so they can have asset model they can use for efficient management and the maintenance and process, operation and maintenance process of that particular project. And they engaged this organization. It's just 6 minutes video, if you bear with me, and I'll play it for you, and then we'll be done with this section.
Cashier of State Libraries, Archives, and Museums project was the building of a new home for the Alaska State Museum, the Alaska State Libraries, and the Alaska State Archives. When we built this facility, we were looking for another way to store and quickly retrieve O&M material.
In the early stages of the project, when we were working with the owner, it became apparent that the complexity of this building was not something that they were used to maintaining. It's full of all types of high-tech systems for security, clean rooms, artifact preservation, labs, and the client really needed a way to organize all this information, have it easy to access.
We really needed to move into the 21st century.
And the 6D model was a perfect solution for that. 6D is essentially a new technology where you're taking a 3D model of a project. The model is built of the facility and all of its components. It's filled with the geometry, so you can go in the model and see what's where behind the walls or above the ceiling. It's got components that involve operation and maintenance manuals. It has as-built built into it,
so that maintenance staff can efficiently and intuitively access the information.
The hope and the goal was that it would assist the owner after we left to be able to maintain a pretty high-performing building with little to no learning curve after we were gone.
What I was looking for in the 6D model was the ability to retrieve IOMs, something that provided us with a workflow and tracking workflow.
To be able to have full knowledge of what was on the wall, in the wall, under the ground, but we wanted to be able to get that information animated in such a way as that we could operate this building and maintain it.
And we have a declining budget in the state of Alaska, so the economic aspects were incredibly important.
And the solution we ended up selecting was one where that data can be stored on their servers, it can be stored on cloud servers, and there's a lot of flexibility in how that data gets managed and maintained, and it's flexible in the way they can add to it, and it can change and grow as the facility ages. Perfect example of how a 6D model will be useful to a client. Imagine a room filled with walls of binders, stacks upon stacks of construction drawings,
and you're the service tech that has to go and figure out what size of filter to use for this piece of equipment. I'm going to have to flip through all these drawings, I'm going to have to go through and find out which of the 30 plus binders that filter is located in, and that's going to take me quite a long time, could be upwards of a couple hours. It's like searching for a needle in a haystack.
Now, imagine that same room with just one computer terminal that you can walk up to and type in and search for whatever you need.
The data is available instantly. It's an incredible amount of time that you save in that process. Taking that a step further, you can have facility management at an off-site campus where someone could call in and say, you know, I need this part ordered. Someone in a different state can look in the model, open up that component and order it.
So for the owner of the building, having all this information in an easy-to-search database with visual geometry tied to it
really reduces your operations and maintenance costs.
Having the general contractor engaged in the process, you get a level of practicality and application with the execution of the software that the architect cannot give you. You end up with a much more solid understanding. It's got a lot more brick and mortar kind of attitude. I can discern that. I see it in its application of use.
PCL helped us make a very good decision. We were looking for a system that would save us time and money, and we believe it to be the case that we will reduce that time by about 75%.
The hours it saves are incredible.
What would have taken us an hour is now taking us 10 to 15 minutes. My staff and I really enjoy having this tool and find it an invaluable asset. If I moved into another building, I would be looking for this very sort of thing.
Working with PCL to find a solution started from the day they walked on the project.
PCL had a very dynamic and responsive team.
They were great players. Nobody hid from hard solutions. At the same time, nobody threw down what I would consider undeveloped solutions for us to try to fit into.
It's been an incredibly positive experience for us with PCL.
They were really invaluable. Good team.
Okay, so yeah, that's it for now. You can see how the organization utilized that system and solution to save 75%, of time, and also reduce, massively, the cost implication on the operation and the maintenance of that particular facility. So I would hand over to Dr. Paul now. Thank you.
Thank you, Dr. Moses, and for people in the room, if we could show our appreciation in the usual way. Well done. Very good indeed. Very good indeed. Thank you. So it's a great start to the morning. So we're just about to have a 15-minute comfort break. We'll sort of pause, I guess, or keep it running, David? Pause itself. Okay, it'll pause itself. Perfect. Lovely. That's fantastic. and then we'll rejoin you in about 15 minutes time. We've got a presentation by Dr. David Heeson, and then we'll move on to our colleagues at Ramboll who are going to show some real-life case studies similar to some you've just seen, which are some of the partners that are working with us at the University of Wolverhampton. For anyone who's interested in being more involved in QSI, Quant Suzanne is there. Please do sort of contact Suzanne while we're having the break and sort of get to understand on the up and coming events. And if you want to speak to anyone in the research community for Quant International, we have Dr. Ezekiel, there he is, and Dr. Moses. So please do reach out to them. So if you've got any work coming up. And then just a gentle reminder, working with our partners, East Carolina and other partners around the world, we will be hosting a global conference next year in Rio de Janeiro in Brazil. That's September 2023. Start to think about your sort of papers for that conference, or for the practitioners. Again, we very much open this up now to practitioners of the conference to come and talk about your real life case studies. So start to sort of talk about there. QSI is supportive to try and make sure there's lots of members there. We're looking to expand that area of the world as well. So hopefully you can come and sort of join us at that conference next year. There's lots of events in the interim, but I thought let's get it out there so you can start to get the date in the diary. So it'll be the first week in September 2023. Just hold the date and more information will come through our partners at East Carolina, and that'll be the construction in the 21st century, and it's conference 13 I believe. So hopefully you can join us there. Enjoy your comfort break and we'll see you very soon. Thank you. So welcome back everyone, and hope the coffee cups are charged. Thanks very much. I know for some people now you're probably getting to the close of the day, or close of working day at least. So thank you for staying with us. Hopefully you're enjoying the presentations. What we will be doing as well, we've had some messages come through just to say where we can pick the recording and share the recordings. So what we're going to do, Dr. David Heeson is going to speak in a moment, working with Suzanne, will establish the YouTube channel again. We did have a YouTube channel for a while, and we'll reignite that. So we will put this on as our first YouTube link as well, so it can be shared with colleagues and members who couldn't make it today. So that's really useful commentary, and thank you for sharing that. We will do some Q&A at the end. We've got Dr. Moses still here, and Dr. Heeson will be here. So when Dr. Heeson completes, we'll do Q&A and I'll get the panel members up. But without any further ado, can I just hand over now to Dr. David Heeson, Reader in BIM at the University of Wolverhampton, and David's going to talk us through current and emerging BIM technologies and the latest digital tools impacting the construction sector. David, we look forward to hearing your presentation.
Thanks, Paul. And good morning, good afternoon, good evening, good night, depending on wherever you are around the globe. I'm going to try and pull us back on time. Very conscious that we're well overrunning, so I will endeavour to get us back onto some kind of time. You heard earlier about processes, standards, lots and lots of standards around BIM. If you have insomnia, they're a wonderful read to go through the entire ISO 19650 suite. So they're great. We've done that very usual thing of creating lots of standards. Arguably, sometimes that gets in the way, and that's a barrier. Most also mentioned that it's a process underpinned by technology, and that's something that we do sort of quite a lot, along with sort of colleagues like Nigel, who's sat in the room with me today, and the Construction Futures Research Centre as well. So I wanted to look a little bit about them and some of the technologies that we use. Paul said my name's Dave Heeson. I'm a reader in BIM, very academic title. It's a research-based title. So as well as teaching a lot, I spend a lot of time doing research and applied research, working out in companies and helping companies with BIM implementation and technology implementation at the same time. So we wanted to look at some of the technologies. As most of these technologies we're going to talk about, we're using, we have them here in the university, we're very lucky to have them. So at some point, if you're ever here, you can sort of experience them firsthand. But we've gone from that place, from a construction-based way of working, as Moses sort of mentioned, that digital place. We've got into sort of almost like the bottom corner and some of the really exciting stuff around artificial intelligence and generative design, we're going to call it, and I'll mention those in a few minutes. Some of those technologies. We are in a transformational point. We're at, we call it very often, we call it the singularity point, I think, for the construction sector, where everything's sort of coming together at the same point. We have a generation shift in the sector who are, in phrases, the digital natives, who are digitally enabled. So we have people coming in digitally enabled. We're at the point where software is caught up. We're at the point where hardware is cheaper and more cost effective. And so we're at this stage where all that's coming together at once and we can have this massive transformation in the industry. And we're living through it. You know, since the whole BIM stuff, and by the way, I'm kind of falling out of love with that title as well, because we say it so many times that it almost just goes off our radar. In the same way, think about this in the 90s, those of us who were around in the 90s, working in the office then, we all talked about, have you produced the CAD drawings? Have you produced the CAD drawings for that project? And then all of a sudden that disappeared and it was just, have you produced the drawings? Because there was an assumption that we had used CAD packages to produce the drawings. So we're going to get to the point, when we stop talking about BIM, we'll have succeeded. Because it will just be part of the natural way of working. And the same way with some of these other technologies. So we're going to look at some of these, try and give you some examples, talk about them. Nigel, probably you can chip in, whether you want Nigel Moore. Dr. Nigel Moore is up there. Nigel is sort of an expert in the VR, AR, generative design, artificial intelligence. He's just a geek like me. In other words, that's what we do. So we're going to look at some of these. So I wanted to run through some of the things that are happening now, some of the things that are starting to evolve and some of the things that we're engaged in using. And the first one that kind of excites us around this BIM, in inverted commas, workspace. And that's the onset of artificial intelligence and where we're going with that. And we engage with artificial intelligence every day, we just don't know we are. So when you go onto a website and there's a chat bot, that's not human. That's an AI sitting in the background. And that AI is looking for keywords and then it responds to you. That's one. You know, when we go onto Google, not Google, when we go onto our banking websites and it asks you to select everything with, before you go any further, select everything with a traffic light in it. You're training Google's AI, ready for driverless cars. That's what we're doing. So we're taking that on as well. And the subset for us around this is GD, generative design. Massive for us as a construction industry. The applications off the charts for us going forwards. Because what that algorithmically allows us to do is give parameters to a design package and tell it to optimize it. Come up with hundreds of ideas. We do it with our architecture students. Our architecture students could spend hours and hours with bubble diagrams of saying, well, we want this space to be related to this, and what's the best approach for doing it? Hours and hours. Give those parameters to the machine, we'll generate hundreds of options for us. Hundreds in seconds. And then we just then, as humans, go through and choose the best ones. So it's all that AI side. Why is it important to us? Well, look down here at this. And this is some sort of report looking at where the application might go. And the big application for that, this is in the construction sector. Look in here. The potential growth of this by 2026 and planning and design is massive. Massive. It will become part of our workflow. That scares me as well as excites me, because we're kind of moving towards the Terminator level side of things, possibly. But That's really cool. So generative design is one. And we have it for things like these. These are some examples. We have it for floor plans. You move the boundaries of the floor, it rearranges the furniture, it adapts and it optimizes the positions of the furniture. Some examples of where, where things could go. The first time I ever heard of this, I was actually at an Autodesk University conference in the US. First time I ever heard of it. And they told the story of, was it Boeing? I think it was Boeing or Airbus, I can't remember which one it was now. One of the big companies. And the bulkheads on the aircraft, between like cabin 1, cabin 2. And they used generative design. And what they used it for was to optimize the amount of material that they used, the amount of metal that went into that bulkhead. Because more metal in that bulkhead equals more weight. More weight equals more fuel. More fuel equals more carbon emissions. That's how it works. So what they've done is given the same design parameters to the GD algorithm, generative design algorithm, and said to it, keep the same structural integrity, reduce the amount of material. And it had gone through different design cycles and done it. And it was crazy, because they kept all the parameters of it, and they'd reduced the weight of each bulkhead by whatever it was, like 10 kilograms. You multiply that out by every bulkhead on an aircraft, and it reduced the amount of fuel that was used. Then you multiplied that by their entire fleet, and they were saving millions upon millions every year in fuel costs just by optimizing the design. And why didn't a human do that? Because we don't have enough capacity to make all those design the system did. So what would happen if the Golden Gate Bridge had the same parameters and was put into a generative design algorithm? So it doesn't always get it right. It doesn't always create something that is aesthetically pleasing to us, right? And I don't think that would be something that you would be lining up to take your picture in front of. Then it wouldn't have that picture postcard thing. But from an optimization point of view, it could be structured like that. It looks bloody awful, but it would work. It's functional. So there's got to be that human intervention somewhere in it. But what it's also allowing us to do is come up with these kind of shapes. And you're starting to see these now, like we saw some of the stadiums and things like that. All those shapes are coming up because the systems are allowing us to do it. And the systems are allowing us to do it because we've started to adopt digital technologies. Couldn't do that by hand. It'd be very, very difficult to do it. So it's all starting to come together. And it's kind of a cool place. So generative design, one to watch. GD. And we've done some work. We're working in this place as well. I'm working with Nigel on this. We're working on a UKRI funded project called Stella, which is about off-site construction. And we've used generative design to firstly optimize the design of a house that's prefabricated and made off-site. And we've then also used it, I guess with more limited success in many respects, to optimize the layout of the factory, to make sure that what's going through that factory is actually as fast as it can go through as well. So we've used all those things, all those constraints to do it with. And something else that we're really into, and we're doing a lot of work in here, which is really impacting the industry and transforming it, is digital data capture. And it's quite a broad term now. Traditionally, it's only been around about 10, 14 years, but realistically, it's very often assimilated to laser scanning and point cloud data capture. And if you haven't seen sort of one of these things from the past, that's a terrestrial laser scanner, LiDAR-based laser scanner. It's a tape measure on steroids plus steroids plus steroids. So that's an example. This is a picture of the one that we have here in the institution. It's a Faro focus. It will take 1 million measurements a second, and it will go down to millimeter level accuracy. Sub-millimeter if we really wanted it to, but millimeter level accuracy we'll go down to. And these are some examples of some of the projects that we've worked on. So we're able now to capture digital data. We're able to capture the geometry, capture the fabric of a building in detail and accuracy that is just hasn't been available to us. Measured building surveys, I can go and do that in a few seconds, which may well have taken us hours, possibly days beforehand. So there's an example at the bottom here. That's an old building in Telford, well in Madeley near to Telford, that we captured a couple of years back. It's a historic building. What we do with that data then, we're able to use that and generate a 3D model from it, from that, which we can then use. That's great, that's cool, that's sexy, it looks nice, and all the rest of it. But there's issues with that. First of all, we're not generating a building information model. People say they are, people will use the term scan to BIM. It's not. Because at the moment there's no information in that. It's just geometry. So, like we say to students, it's scan to BIM, because it's building model, not building information model. There's no information in it. Secondly, issues we've had discussions around, and we've had discussions with good friends at the Seven Partnership, who we work with, a topographic surveying company, we work a lot with them, and the engagement with the RICS on this as well, where it's not a wonderful tool, but you can't take off, you can't do takeoffs from it, because what you model is what you see. So in this building, for instance, we would model what we could see. Now the slab depth, or the slab, where the slab extends to, might be sort of another 100 mil all the way around on that. We don't see that, so therefore if we measure from it, it's incorrect, because we're missing the volume out. So there's issues around it. Not insurmountable, but if we, let's be honest about great technology, but let's also be honest about where some of the issues lie with those technologies as well, because we can't just assume they're a utopian vision and they solve all of our problems, because they don't. But very, very cool. Now, with that, and with that data capture, and with that sort of LiDAR technologies, that LiDAR technologies with the scanners, they will shoot a laser out. They're built on something called LiDAR, which is a pulse laser, shoots a pulse laser out, hits a surface, rebounds back, measures the distance. That's how it's doing it. But it's doing it about 1 million times a second, or it can do up to 1 million times a second. So from that, you generate a point cloud. And I think this is kind of the nicest one we've got so far with one of our projects. We've done lots and lots of projects, but I really, really like this one. This is the Dudley Priory, just down the road from us here. I think it's 986 AD, something like that, it was built. And we just happened to capture it at the right time of day with all the colours on it. It's amazing. But you can see as you zoom into it, it's dots. It's not generating geometry, it's not generating 3D CAD data, it's generating dots. Every dot is a measurement. And we can put colour on it. So the scanners that we use have cameras built into them, so it also captures the image as it goes around, panoramic image. So it's shooting a laser out, whatever it hits, it measures, then it also takes a picture of it. It takes, from that picture, the RGB value, the red, green and blue value, which gives you the colour, and then it maps that colour value back onto that point as well. So that every individual dot now has an X, Y, Z coordinate in space, and also has a colour component. On top of that, it also captures the intensity of that. Great for doing highways or defects in buildings. So when the laser shoots out, hits the wall over there's a white wall for those of you who can't see what I'm looking at, and the laser rebounds off a white wall and comes back to the unit, it's got a different power level. Some of that laser energy has been absorbed by the wall. So when it returns back, it only comes back with, say, 95% intensity. When it hits a dark surface, even more of the light energy is absorbed, so it only comes back with, say, 50% intensity. So it records that as well. And so you can see in this centre little image here, it's black and white. It's actually not black and white, it's different intensity levels. And that tells you the materials are different. So great for road markings, for example, black and white road marking, because when the laser hits the white thermoplastic, it comes back with a stronger return than if it hits the black wearing course on there. So you can do that. Brilliant for measurements, brilliant for generating models. We also have, we're moving into a different way of working as well. So you may or may not have heard of a technology called Matterport. They're really, really active in the AEC workspace at the moment. If you search Matterport and University of Wolverhampton, you'll find a massive spread that we did last year with them. Load of articles on the application of it. That uses a lower resolution method of capturing three-dimensional spatial data. And the best way to describe it, the technology that's inside it, it's very much like the Microsoft Kinect that you used to have on the Xbox. It's infrared. So it only works up to about 3 meters away. So it captures depth information, lower resolution. It's about 50 millimeters resolution between it. So if you've got sort of something that went like this coffee cup, like that, it won't capture all the detail on that. It'll capture a point there and maybe a point here. So it'll look like that. Whereas the scanner will capture every millimeter. So you will see the shape. So you don't get that detail. The Matterport also captures 360-degree images from it. And that leads us into what we call something called photogrammetric solutions as well. And that's building 3D data from photographs and from images. That's somewhere else we're going, because that now allows us to, it's computer-based, it's digital, it allows us to generate 3D data from two-dimensional flat images. Drones, we have a drone expert, and just finished his PhD in that field. We're now able to capture two-dimensional photographs from different angles, and we build reasonably accurate 3D models from that. Something else, so that's building into BIM workflows, that's building into construction workflows as well. Another set of technology that's now coming online, something called SLAM. So we have those that we've seen there are based on static setups. So if you went back to the very first slide, you know, we had total stations where we could take one measurement, but you set up in one place. And the same with the scanners, you set up in one place and then you have to move and then you have to move and you move. When we come on to SLAM technologies, SLAM means simultaneous location and mapping, you can move, you can walk around with them. So we're fortunate here, we've got, in the university we have both of these technologies available to us now. This one is called NavVis, which makes you look a little bit like a stormtrooper when you're walking around in it. And this one is a Leica BLK to go. But we walk around with them. And as you're walking, they're capturing 3D data, so they are scanning, and they're also capturing images. And post-production, what's happening in post-production is it's stitching all that together, putting the algorithms behind it, and it's then generating 3D data, a point cloud for you. Much, much quicker to do it. Simpler to do it on site. Walk around site. All right, you look a bit daft walking around site with one of them on. But you can capture now during construction. We always talked about as-built. You know, we've got design, then we talk about capturing data as-built. Now we can capture during build. And that means that we can monitor more accurately. And we've done that project with ISG, who built this building that we're in at the moment. We worked with the contractors and we captured the data as it was being constructed, and then we validated the construction work against their 3D BIM to see if it was good, accurate. I won't say what some of the things we found. I'd leave that to ISG to talk about that, but it was interesting to do it. So they're technologies that are coming out, scanning technologies. The price point is dropping and dropping and dropping. We're not talking tens of pounds, we're into the thousands, sometimes the hundreds of thousands of pounds, but they are dropping continuously, and they will do. Where we're going next, for anybody who's got an iPhone, or an iPhone 12 or an iPhone 13, you have a scanner on it as well. It's a low resolution scanner, but if you've got an iPhone 12 or 13 Pro, at the bottom there's another little lens, and that's a LiDAR scanner. And that is capturing 3D data, or you can capture 3D data with it. So, are we at the point yet of being able to just walk around with one of these on site and capture data? Probably not, because it's not accurate enough. But that's the start. That's the starting point. Give it another few years, everybody will be able to do it. That'll get better, that'll get more accurate. People will find different use cases for it. So we're able to capture 3D data using one of these. That's unbelievable. For an industry that 10 years ago was still drawing in 2D and using sort of AutoCAD, for us to be able to, and we've tested some of this on site as well, for us to be able to capture it using some of this is just incredible. Not for us, wasn't designed for us, it was designed for the games. That's where that comes from. Remember Pokemon Go from 2016? Right, where everybody was walking around in the summer of 2016 trying to catch weird creatures on the phone. And kids, well, my daughter had me walking around all sorts of different places to try and capture little creatures. The issue with that is those creatures existed and they didn't understand their environment, so they were just images on a photograph. So they would walk through trees or walk through cars. So it was designed to solve that problem, because you're instantly developing a 3D environment. So those creatures now can jump over the car because they understand what's there. That's where it comes from. It's just that we've hijacked it and we're going, do you know what, we can use that. It's generally what happens in the construction sector. So, massive opportunities in terms of data capture for that. Where else are we going? All this three-dimensional data, whether it's BIM, whether it's scanning, whatever it is, that opens up the whole world of 3D printing for us. A world that, up until this point, has been about that big, because we could only print that big, because the materials and the technology that's available to us. Now there's something called contour crafting, where we can print in concrete. So we can now 3D print buildings. Expensive at the moment, yeah, but we're getting there. It will come down. If you Google or search for a company called MX3D in Holland, and you'll see examples of this. They're 3D printing in metal. So imagine a big version of a soldering iron, soldered metal. That bridge is now in Amsterdam, and it's been established, and it is actually live, and it's being used. So it structurally works. So we can print in metal, we can print in concrete, we can print in plastic. We've got a printer here that prints in paper. Just takes sheets of paper like a photocopier and prints in 3D from that. So we're getting there with 3D. That's the 3D model printed out there of the Dudley Priory that you saw earlier. So we sort of brought it down, generated the 3D data from it and printed it out. Where else do we go? Well, this is kind of our latest addition to the Wolverhampton family, because we're also now into a pretty scary but exciting age of robotics and wearable computers. And people have been looking at robotics for construction for years, right? You go back to this guy called Leonard Benold in the US, and I met him a couple of times when I was over there. And he was always, his specialism was robotics and construction. Everybody always went to brickwork, because robots in manufacturing, they do repetitive tasks. You think about what repetitive tasks there are in construction, brickwork is the general one that everybody comes back to. Place. So a lot of the focus on robotics went into the brickwork genre than that. And the problems, static robots, couldn't move them anywhere, or big job to move them. Now you think of, there's a company called Boston Dynamics in the US, come out of MIT, and they started to develop robots that moved autonomously, and they started to develop biped robots, human robots. We're talking like Terminator level robots, like these. And they will move and do tasks that we will do. And if you kick them and push them off balance, they come back. like we do. They have all that information in them. So, from our point of view, now we've got robots that potentially could do tasks that aren't bound by a set working envelope, not just bricklaying. Do anything. Send them up high level working, remove the safety risk. There's also wearable technology as well, if you look at this bottom one here. So we now also have technology, and these have been tested on site down in London, exoskeleton systems that you wear, removes issues of lifting injuries because you're letting the system, kind of like RoboCop. RoboCop had that, the things that made them do extra thin. It's that. The weight and the strain has been taken by the exoskeleton, by the machine, not the human muscle. So we now have wearables. From our point of view, this is our latest friend. I'll turn the sound down here at Wolverhampton. This is from Boston Dynamics. And we've just taken ownership of Spot the dog, which is not biped, it's a quadruped. Let's get rid of Paul, we don't want to see him. He's a good looking chap as he is, we don't want to see him. The dog will walk up and down stairs, walk anywhere. It will go anywhere. It self-corrects, it self-levels itself. It will avoid objects autonomously by itself. Why are we interested in that? Well, it's kind of cool anyway. But why we're really interested in it is it can take a payload. So if we look at him here, Spot, on the back of it, just at the top there, we can put one of our laser scanners on top of it. Put our laser scanner in it, we can send it into a building that's dangerous. We could send it into a building that's got asbestos, for example, where we don't want to work. We could send it into the nuclear plant, where we only allow so many doses of radiation when we're doing measures. They're the issues that we can use it for. So that starts to bring that digital workflow, and that all feeds into the BIM workflow, feed all that data into places that potentially historically we couldn't have done it with. So Spot, that sort of robotic autonomous robot, you can see the example there with the scanner on, laser scanner. That's kind of a next evolution. And then we get into something that we've been engaged with for the last 20 odd years, virtual reality and augmented reality. The stuff that in the early days of the 1990s into the early 2000s was massively expensive, mega expensive stuff. The first reality centre we built in 2001 cost us £250,000. Big equipment, very, very sensitive equipment that we built. Now I can go down to Argos this afternoon and buy a VR headset for £300 and have arguably a better experience from doing it. So I could go down to just the high street and buy something. So kind of this is a standard graph we generally tend to use of like the how people perceive VR and AR in construction. And it started off, everybody got very excited, and then we got fed up because it was too expensive and it didn't really work. And then we really, really got fed up with it because we couldn't be bothered with all that, and we didn't work in 3D anyway. And then we started to talk about BIM, and we started to talk about working in 3D. And now we've got data, so now we've got 3D data we can work with. Then the cost of the hardware started to drop down, arguably because the likes of Zuckerberg and Facebook bought the Oculus brand, and then it started to reduce the cost down. Then we had software companies come on stream, like game engine technologies, all this fit with the rise in gaming. The software got easier to use, the software got cheap, even free. That's where we went. So it's no longer, it's not a toy now, it's a serious, serious piece of kit, and we use it. And from our point of view at the university, we started with that, which was $250,000, then we come down to that, which cost us about 50 grand, and now we're into these, which are about 4 or 5 grand. So we're changing how we perceive these things. Software-wise, we work with a company called Seeable, and Nige, director of that company as well. So there's something to sort of look at. AR-wise, augmented reality-wise, that's overlaying it. And just to leave you with a little bit here, because this is new stuff. The National Brownfield Institute across the road from us here, we use this on site with the contractor. We walk around the site and we are overlaying the BIM, the 3D model, directly onto the real world. And you can see the real world outside there. As we're moving around it, we're able to spot issues on site, live issues on site. And we track those issues on site as well. So we're bringing in the physical and the real world. Pokemon Go, it's Pokemon Go for construction and Pokemon Go times 100,000. That's where we are with this. And that's kind of a workspace that we're still working in. We're working with the company who do that called Unity, who have that product. They're collaborating with us on some research in that. And that is kind of cool stuff. Leave you with this one, because this is the thing that everybody's talking about now and nobody really understands, in my opinion, the whole digital twin. And we have many discussions around this, because everybody now says they're working with a digital twin, but not really understanding what digital twin is and how it works. Not a new phrase, been around for a long time. New to us in the construction industry, yeah. And so it's almost like, for me, we got bored of saying BIM, so let's say something new. And we say digital twin, we're not using it in the right context. But something for you to look up and make your own decisions about. So that's me. Happy to have conversations about any of this stuff. I generally spend my evenings reading around this sort of stuff and getting very excited with it. So drop me a message if you ever want to sort of have a conversation about it. But it was a little bit back to time, not a million miles off. Right, there we go.
Perfect.
Thanks, Paul.
Lovely. Again, can we show our appreciation for David? Also, can I take the opportunity to congratulate David as well. He was on a virtual conference in Australia, was it Melbourne? Earlier in the week, and he's picked up the prize for the best sort of paper at the conference. So again, many congratulations, David. And and Nigel, my apologies, the dynamic, the twinning, yeah, I can see where we are with that. Digital twinning team. Yeah, no, fantastic stuff, and they do live this, you know, with our passions. It's certainly what David and Nigel's all about. And yeah, really good. It's nice to share that across the world, so well done. So what I'm going to do, if that's okay, we'll carry straight on, because I'm conscious we must close at 1. So if I can invite now the Ramble team to come and share their presentation, and we very much look forward to hearing case studies. So thank you very much indeed. Thank you.
Hello everybody in the room and online. My name's Ricky Lindup. I'm a senior engineer at Rumble. This is David Lowe, who is also a senior engineer at Rumble. We're going to start by giving a quick introduction to Rumble. So Rumble are an independent architecture, engineering and consultancy company. They're a Danish company founded in 1945. Up to 17,000 experts worldwide, present in 35 countries, and we are owned by the Ramboll Foundation. The Ramboll Foundation was formed in 1972 to take ownership of the company and maintain the long-term continuous and provide an inspiring workplace for colleagues. The other 2% of shares are owned by the employees themselves. As I said, we've got a geographical footprint. This is where we are present, so really present in Europe, more of a presence in America, presence in Asia, and within the UK we've got 16 offices located across the country. Okay, a little bit more about me. I'm a senior engineer in building services engineering with a mechanical bias at Ramboll. I've been at Ramboll 4 years. I started in the industry in 2007 as an apprentice, so did part-time college to get up to H&C, did part-time university to get a BN Johns, an MSc. I'm an incorporated engineer with the Engineering Council, and I also possess a member grade with CIPSI. Some of the key projects I've worked on are Valencia Arena, which is this image here. That is due to open in 2024. Gibraltar National Stadium, which is this image here. That has actually been stopped, but it's due to restart soon. Cultural assets buildings in Riyadh, Saudi Arabia. These were really complicated projects to work on because we had to try and fit modern building services and structural design into traditional Najdi architecture. And I'll hand over to Dave.
Thank you. So, my name's David Lowe. I joined Ramboll in 2014 as a graduate. You can see a few key projects there. Proud to say each of those projects has used some form of digital engineering. I'll not use the BIM term too loosely. As you can see on there, I'm another senior engineer with Ramboll, mechanical bias. And since joining in 2014, I'm really pleased to say there's been a huge development in digital in the industry, and the development of BIM as well. So just what I'm going to quickly run through before we get into the case studies is what we can really use that I in BIM for, what it enables us to do, and the improvements that we can make in the industry on projects for clients, and just generally being more responsible engineers as well as we go through. So the first one is it allows us to be engineers faster. One thing we've started developing at Ramboll is something we call parallel engineering, whereas the older traditional storyboard days, as we've mentioned, drawing board days, would be, you do analysis at key points of a project, and at each of those key points you'd update the information. What parallel engineering allows us to do, thanks to BIM, thanks to sharing information, collaborating with other stakeholders in the design process, it means that we can analyse that data iteratively. We can do it more often. We can do it automatically. So this example here is us taking the building fabric that we get from architects in a Revit model, for example, analysing that space, analysing the heating and cooling demands, and automatically putting in the right sized heating and cooling terminals in those spaces. So rather than us spending a week reviewing an architecture's update, going through, selecting heating and cooling terminals, it's done more autonomously. We can spend that time doing other things then as well. So, terminal units, yes. Another long process that traditionally we'd had to do would be circuiting. Look at the distribution boards. It's really a manual process of circuiting sockets in a space. You might have a large building with thousands of these to do. What we can do, because of that standardised information that we get thanks to BIM processes, and thanks to sharing that information between architects and engineers, we can automate the process of doing that circuiting. It's not putting 3 human beings for 3 weeks on it. It's allowing the technology, the hardware that's been mentioned already this morning, to good use, and to automate that process. It's not just MEP, obviously. Structures and civils do a similar thing. What this little quick demonstration here is just allows us to quickly alter the parameters for the building that we could be looking at, allows us to review what impact that has, nice and visual as well, which is another huge benefit of these workflows. You can see immediately, you can communicate with clients, with other parts of the design team, what the impact of making these changes is going to be really early on a project. It's information that previously you wouldn't have looked at until really late in the design phase, when it's just too late to make these changes. But now we can review it, we can look at that, present it, and come out with better solutions faster. As part, again, with the standardised information sharing, with that I in BIM, we can use standardised tools ourselves. We can automate some of the design processes for drawing pipes and ducts and sizing services. All of that information's there in the model, ready to use. We can leverage that information, develop designs quicker, more consistently. Risk, again, what we like to do is use that information as early as we can. I think it was mentioned by Dr. Moses earlier this morning about using that information earlier in the design process improves quality, but it improves the risk as well. Here's something we developed at Ramboll called BEAR. It's the Building Early Assessment Report. As early as just getting the geometric data of a site or a building, we can analyse that and de-risk and advise and review optioneering really early on in the process. So just a couple of the sort of tools that we've got here. There's looking at the climate in detail and looking at opportunity for passive servicing as early as sort of stage 1, 2, when all we have is sort of a location and a building form. The DSO tool at the end, again, that's looking at site massing to make sure that we're optimizing the daylight, the shading and the overshadowing, and we're meeting design criteria that we might have to meet way before. In a traditional design we would have had locked in geometry that we would have had to analyse, and now we can influence that earlier on and improve the quality of the work. So quality again, you might have had a team of engineers doing some paperwork in paper designs in the olden days for sizing and selecting terminals and things like that. You have 3 or 4 different people working on it. They'd be using 3 or 4 different software tools. One of them would be writing it down in a schedule at the end. And there's so many opportunities there for issues, for human error. So with a common data environment, with the tools that we've got, all of that information can be put into one place, can be referenced from one place, and that means that there's no, or reduced options, I should say, for quality issues. So again, this is all standard workflows that we're using at Ramboll now. It's standard tools that we have access to, and it's helping us improve the quality of our work. Electrical, again, just as an example, it's no longer a piece of software looking at the design of cable calcs and another piece of software looking at the design of outlets, and then someone then converts that into a drawing by drawing it on a piece of paper or in CAD. It's all in one place now. We can add that information into the model. We can use that information consistently. We can do designs from that information, and it means that workflow is less prone to risk, can be updated automatically, can be monitored, can be measured, can be checked. So on the left is kind of perhaps what you might be more used to seeing for building services design. It's tabulated data, it's a lot of numbers. If someone's going to go and check that information, they'll look at each line, they'll try and find it in a plan. We don't need to do that anymore. Because of that data environment, because of the tools that we've got, the software and the hardware, we can use visual checking. So it's much more intuitive for humans to go and check that information now. It's much easier and clearer to see what the difference is between those services and spot any issues, spot any anomalies, and we can correct that or review the calculations, for example. So data, I've mentioned it a lot so far, but using that data, that information that we have in models and collaboratively means that we can really start measuring and improving our processes. So here's just a quick snapshot that we've got of recorded sustainability data from project that we've done. That allows us to have sort of our own internal benchmarks when we're sort of delivering projects. Those benchmarks we can look to ourselves, we can share them, we can use them to influence design, see what's worked well. We can learn from those past projects a lot easier with that information to hand. We can present that easily as well. So the graph on the left here is a sort of standard design profile that we might have, and then overlaid underneath that is an actual profile that we've got from a client. So you can see there's a real mismatch in the loads and the peak that we need to design for. What that means is that we can better design future buildings so that we're not over-designing. We're designing to realistic, real-world uses, and that information that we have feeds into the design in an early stage. In future projects, we can design leaner, more efficient buildings. So the graph in the middle, again, it's the same thing. We're talking about the histogram there for annual temperature for one of the projects, you can see that that winter season is quite small compared to where you've got that simultaneous and heating and cooling load in the middle and just the cooling load at the end. That means if you look at the graph on the right, we can design the building services to work more effectively, more consistently throughout the year. It's that information that we now have access to that we can use to better design buildings. Get rid of the rules of thumb that we would have used 10 years ago, and we can actually start improving the industry and improving the quality of projects that we work on. So again, that's just sort of explaining the same thing. Compliant buildings, best practice buildings, and then high performance buildings. You can't get to a high performance building unless you really understand it, unless you get that data, that information, and you use that to influence your design. If we're talking about low carbon buildings need to be efficient buildings, and until we can really understand it and apply that, we're not going to get to where we need to be. There's a statement there, over 80% of professionals see reduced operating costs as an important benefit. Again, you're not going to get those reduced operating costs, those reduced carbon, by using rules of thumb. You need to use the information, the data that we do have access to now to influence design. So again, there's a few more options that we've looked at here. Again, really early stages. We have the geometry data, let's use it. We've talked about algorithms as well. We can use these algorithms to optimize buildings to be better performing buildings, to be more effective buildings, to be more cost-effective buildings, improve the user experience in those buildings ultimately. So here's just improving views to a certain direction by changing block heights. So this isn't changing the floor areas in total, but we're better using the space that we have with a parameter that we can control to achieve a client aspiration of better views, for example. So you can see there, it's made a big difference on this project in particular. With a 50% unobstructed sea view, we've improved that by 50%. Just by changing the building orientation slightly and the positioning of those buildings, we've better improved the building itself. Maybe that means that the client has got a better value building, a better quality building. Sustainability, I mentioned carbon already, but it's obviously a real focus area for us in the industry going forwards. We were tasked a couple of years ago now for British Antarctic Survey to look at how their new stations in Rothera and the Antarctic could be sort of optimised, how we would service that. What we were able to do is do a data-driven approach to review a great deal of options, as we've touched on already with genetic algorithms, so that we could optimise that building, optimise the limitations that we knew we had to work around. So if you're in Rothera, you have to get a ship to get fuel. So how much fuel do you want? When do you want it? Do you build diesel engines, CHPs, gas boilers? How do you optimise that with the limitations that you know that you have in that building? So you can see there the sort of mountainous picture there is just reviewing different fitness options. And you can see by changing a couple of the parameters, we can optimise that in a few different ways. And then the sort of graph on the right is the circle showing sort of the limitations that we actually have on the site, and picking one of the solutions out of that. But in the old way of doing it, all of those blue dots and those green dots are analysis of complex systems that you wouldn't have been able to do with humans, with the data, with the parameters you want to look at, with the building information modelling, building information that you have, be that geometric or other information that you have in the model. You can analyse that and review that now much earlier. So again, this is another sort of key client that we're working for. They've got existing office stock, and they want to know how to improve those buildings and how to get them closer to their net zero carbon targets that they've got. So we created a dynamic model. We did some site surveys, we looked at metadata, we calibrated that metadata then against what we would analyse so that we could get in our analysis a really close match to what their real life actual use is. But going forwards, we wouldn't need to do that if it was a fully BIM enabled process. If they already have that operational data there, if they already have that metadata, that usage data, if that's in their in-use BIM process, we'd have access to that. We could improve the building stock then, review options for how to improve each one of those more autonomously and more accurately than we otherwise could do. But this is the process we did without that data, relying on the metadata and our own engineering knowledge as well. You can see each one of those dots again is a different study for best fitness. You see how many there are, and you wouldn't be able to do that without these digital tools. We're able to use this information to improve the sustainability of each of these buildings, each of these projects, so that we can better meet the future requirements for net zero carbon and low carbon operating buildings. So another one, residential in Cyprus, you see each of those parameters that we have access to, each of that information, we can then plug that back in and analyse that and review it with genetic algorithms. That's all of the studies that we've done, and you can see the combinations of passive interventions at the top there that have come out with the best results. So yeah, thank you for that. I'll pass you over to Ricky to go through more detailed analysis, more detailed case study.
Well, I'm going to talk to you about RunView. It's similar to what Dr. David discussed earlier, the VR suites, point cloud surveys. Rumble have just called it RunView as a branding exercise. So what is RunView? RunView is like, in simple terms, is like Google Street View or Pokemon Go, as Dr. David described it. And it allows a client and project team to view and interact with reality capture data, so point clouds, 360 camera images, BIM models, and engineering simulation results in one location. It allows instant comparisons to be made from anywhere between existing assets, new building designs, and the progress of the different teams and disciplines during construction. Another key aspect of this is it avoids costly site visits. I'm working on a project in Sweden, which I will discuss a little bit more later on in the presentation. And obviously, 900 miles away, it's not an easy place to go back. So RunView has been integral to the success of that project. So RunView is almost like it's a central hosting platform. So we've got the 3D Navisworks Revit, which can be loaded in. We've got the analysis results from IES, which is a thermal modelling software, TAS, and we've also got the point cloud data, which can be put in. So we have used RunView on HMS Warrior, Portsmouth Historic Dock. This is a tourist facility, so regular site visits weren't appropriate. So a point cloud survey helped the design teams to get around that. Lawrence Hall, so that's what it looks like in reality. That's the point cloud survey, and this blue is a CFD analysis which has been loaded in, which I will hopefully show you later. And then the Mary Rose Portsmouth Historic Dockyard, because of the nature of conservation of the Mary Rose, we weren't able to do many site visits. So again, a point cloud survey was integral to the success of this project. So Avicii Arena. What is Avicii Arena? It was built in 1989 to provide a new multi-purpose arena in Stockholm. It has a seated capacity of 13,850 for ice hockey and has a capacity of 16,000 for concert performances. It's actually hosted the Eurovision Song Contest twice, in 2000 and 2016, and at the moment it is the largest spherical building in the world. So the required alterations from our client for the Avicii Arena, so this is an existing section, this is a proposed, so this is Tier A, Tier B. These seats sell out quite well, they're used quite regularly, they're nice places to be. Tier C, not so much. So the intention was to demolish Tier C and install some skyboxes. So this is the aspiration. So this is the Little Caesars Arena in Detroit. So it's more of a premium VIP package just to get Tier C back in use, and also so the Avicii Arena can offer premium seats. So this is an architecture render. So some key client aspirations were for us to retain and reuse existing principal building service installations and only relocate services where the structure required for the new gondolas and acoustic ceiling, which I will come on to in a little while, are being put in, and aligned services below the gondolas, so the skyboxes, which I will show an image of later on. So the above means existing build services installations need to be digitalised in the BIM environment, and RunView was integral to the success of that. So another required alteration, the acoustical performance within the Avicii Arena, particularly when there was ice hockey matches on, was not good. So we've had an acoustician design a retractable acoustic ceiling in the shape of a Pringle, and as you can see, each one of these is a new structure which will connect to a column which will affect the building services installation, which is why digitalising the existing building service installation in a 3D format was important. So these are the scope of MEP engineering services. Green is areas part of the scope, orange is areas outside of the scope, and yellow is areas not part of the scope. So this is actually an image from RunView. We use 360 cameras, not a point cloud survey. So this is the MEP ring at level 12. This is where the main MEP distribution was. And the MEP digitalisation workflow was to use existing record 2D information. This was 2D scans of drawings from 1989. We don't know how accurate they were, but that's all we had to go off. So RunView complements the 2D information in order to get an accurate picture of what is already there. So this is an image from RunView. Each one of these blue dots corresponds to a camera position. As I said, it complements the existing 2D record information. Proposed architectural, structural and MEP Revit models can be linked and loaded in order to assess the impact of the design quickly and early. And it was a very useful tool for working on a project which is 900 miles away from Birmingham. And at the start of the project, site visits weren't able because of the COVID-19 restrictions. So this is an image. This is the camera. This is a camera scan, and also the structure required to hold up the acoustic ceiling. So as you can see, the new column does actually clash with the existing services. So it's a very quick tool for us to sit down with the structural engineers on a Teams call in person and say, the column clashes with our building services design. Is there anything we can do to the structure to avoid this, or do we need to modify the existing services to avoid this? Again, another image. So as you can see, more clashes. The access to the existing ductwork and cable containment is also affected. And this is tier B. This is the existing ventilation installation, and this is a RunView with the new structure put in. So as you can see, tier C has been demolished, but we're replacing it with the skyboxes, and the skyboxes actually will block all of these ventilation services. So we need to reroute and repurpose this air in order to provide a comfortable environment for the people sitting at tier B. So this is almost an evolution of where we were. So we started off with nothing. This is geometry from the architect and structural engineers. We use 2D information, which is, there's a little screenshot of that there. We also use RunView to make sure, because a lot of existing record information is not entirely accurate. RunView allows you to measure, so we could look at the 2D information. If something wasn't clear, we could get on RunView and just make sure that what we were looking at is what we thought. So the evolution is, we started off with nothing, and yes, this is each quarter, so it's obviously a circular building, so this is each quarter. So we developed the existing installation at high level in order to assist with the design. So this is an image from RunView. So this is, as I said earlier, this is a structural model loaded in with the clashes to the existing services, and this is Revit 2022, which our technicians developed using the 2D images and also RunView. I'm just going to run through a few examples of RunView. So this one, Lawrence Hall, is quite interesting. Lawrence Hall is it's an exhibition centre in London. It's owned by the Royal Horticultural Society, and so if we click on that dot, that's a point cloud survey, but within this one we've actually inputted the CFD analysis, so in real time. So this is after 10 minutes, 600 seconds. So if I click on the different temperatures, we can actually see, so if we look at this legend, this is about 24 degrees. we can actually see visually the temperature in the space, which normally will be stuck in a report. The client may not understand it, the eventual client, and it's a good way to demonstrate to the client where the different heat spots within the building and where it is, where the problems are. So obviously 22.9, that is quite high. We want to keep this space to about 21 degrees. So as we move on, so 30 degrees, this is uncomfortable. So we only have 30 degrees in that area. It's just a good visualisation tool for the engineers, the design team and the client alike, so we can see where the issues are and look to mitigate that. And here's maintain the temperature at 25 degrees C, time varies, so after 35 seconds, that's what it looks like. 85 seconds, 235 seconds. So it's a very good tool. Usually the CFD analysis would be in a standalone software package, IES, and this just brings everything together. And this, along with the structural model, the MEP model, the new architecture model, we can really give the clients an informed opinion, and also the design teams an informed opinion of where the problems are, where clashes are in real time. This also, as Dr. David was mentioning earlier, can be utilised with virtual reality headsets. So it's quite an important tool. I'll just go through the Mary Rose because I find this quite interesting. So if we look at this, so this is a point cloud survey. So obviously we can't visit the Mary Rose on a regular basis. This project actually involved keeping the Mary Rose in situ and building a museum around it. And this was also used for CFD analysis because there were for the restoration purposes of this of the Mary Rose, there were temperature limitations we needed to keep to, and I find this quite interesting. And here's just this is a boiler house, so again CFD installation. So this is a boiler house. I'm not sure where this building is, but it gives us surface temperatures, so 40 degrees C. So that's obviously the heat from the boilers rising. 48 degrees C. So the 48 degrees C is concentrated around the boiler, the heat generation equipment, and it just gives an overview of where the problems are, whether it's too hot. The plant needs to be maintained at a certain temperature to work properly, and it's just a very, very important tool. Yeah, that's fine. Yeah, I haven't actually looked at this one myself, so. Yeah, so this is similar to what Dr. David was describing earlier. I'm not sure what this was used for. It may.
So we were actually involved in doing sort of the structural review of the existing building. So this was our way of measuring. I think each one of these components was cast iron. It's going to vary slightly in dimensions. You're not going to be able to send someone up there with a tape measure to measure everything. So this was our way of using point clouds to get some more accurate dimensioning of all of these elements. So you can see there, I think the different elements were colour-coded for different sizes, and it allows us to do the structural review then as well, make sure this sort of heritage landmark is safe to operate, it's usable. Any refurbishment works that needs to be done, that information's there ready to use as well. So it's another local example.
And that's us. Thank you very much for listening.
Okay.
Thanks very much. So thank you very much indeed. Great presentations again, and the Mary Rose, yeah, that fantastic. It's interesting, some of the dates, just to give context to some of these things. So Mary Rose, we're talking sort of 1500s, aren't we? The Priory, where David was talking about, just because I did history projects on these things, that's where Queen Elizabeth I sort of came through that building before she stayed with Lord Dudley in Dudley Castle. So, you know, this is all sort of history we're capturing here. and preservation and heritage, which is fantastic. So hopefully you've really enjoyed, I certainly have, and I know people in the audience have sort of really enjoyed those presentations today. Fantastic presentations. As I said, they will go out on YouTube. We've had a couple of questions in though, so if I could start with some online questions and then we'll go through, and I've picked one from, there's lots, but we'll pick one from everyone. So Dr. Moses then, so will all countries be using the same standards you made reference to, or will there be a regional, national or global standard in the future, and how will that work? That's a big question. Do you want to come down, or so people can hear you? Sorry. And David and Jens, are you okay? Sorry, otherwise people won't see and hear your answers. That's a big question. Okay, you want to step in, Moses?
Okay, thank you very much for your question. The standards are, for example, the past standards were UK-centric. The terminologies used and all the considerations given from industry practitioners, the feedback from industry practitioners was what informed the development of that UK-centric standard. But now there's a transition from past documents to ISO documents is now applicable to different countries, and countries can tailor their practice. Countries can tailor their practice, can tailor the standard rather to reflect their practice, but the basics will not change. The basics remain the same, but it could be applicable, it could be customized depending on the practice requirements, regional requirements, cultural requirements, and all that. So just like some of the standards and the UK practice is still annexed to some of these standards, and then countries like other countries in EU and America and other countries that wants to implement ISO standards can make it bespoke in terms of the practice that is dominant in that particular country.
Thank you, Dr. Moses. Very useful. So, question for Dr. Heeson, Dr. David. So, when do you feel these technologies, which obviously what you were talking about, will be more accepted and more commonplace on Hong Kong projects? So, this is a question from Hong Kong. Noting we already use exoskeleton suits.
Okay, when?
Oh, yeah, when?
Hopefully nobody's going to hold me to any time scales on this one. First of all, great to hear that exoskeletons are being used now, because I think that's a massive step forward in terms of cyber. We call cyber physical systems, so the connection of humans to digital. In terms of when, any of these things have an adoption curve. Any technologies have an adoption curve, and it's normally sort of it goes up, then it comes down, and it goes up again, and we call the top of that the peak of anticipation, when everybody gets excited by these, and then we drop off that peak and we come down the slope of disillusionment, and then we pick back up again into the slope of productivity and then acceptance. Now, and that's generally a technology adoption. That's for anything, right from us using Amazon and eBay right through to us using these new technologies. Where are we now? I think at the moment we're at that anticipation and that excitement stage. I think at the moment, because it's cool, because it's new, it's cool. Certainly with some of the autonomous technologies like the robots, the Boston Dynamics stuff, it's cool, it's exciting. I think we're yet to go through that little bit of trough of disillusionment where we might think that we might want them to do lots of things and they can't do it. And then I think we'll find what they can do and we'll hit an acceptance level. Timeline, it's really difficult to put a timeline on that because it's so new at the moment. I would anticipate, and this is just purely looking at where we've come, in the last, you think where the industry's come in the last, sort of 11 years, and the industry's gone from being an analogue, I would say an analogue, very traditional industry, and I know, Paul, we've talked about this before, now I class construction as a high-tech industry now. And you saw that with the guys, the stuff the guys are presenting is just phenomenal. So in 10 years we've gone from analogue traditional, I think, to a high-tech industry. Give that another 10 years and I think then we're going to start we'll see autonomous drones flying around on site, doing site surveys for us and monitoring things quite easily. We're starting to see autonomous vehicles on site and plant moving around site, so we're going to get to that. We will become used to it in much the same way now that we're used to, we just log on to Amazon. You want to buy something, you don't think about what shop to go to, you just go to Amazon. Right? We've changed our mindsets as to how we work. And I think the industry in the next 10 years will change their mindsets with that. And it's, if these guys are using exoskeletons, that's massive in its own right. So for me, and nobody hold me to this or sue me in 10 years or whatever it is, but I think sort of 10 years time, we will be quite happy to sort of coexist on sites, in the design office with the AI, we'll coexist on site with autonomous or semi-autonomous technologies, and then who knows from there. It's kind of scary to think past that, because then we're into potentially sentient beings. That's a whole other ethical discussion.
Thank you, David, and thank you for the question from Hong Kong, and obviously within the message you just highlighted, it's annual, it's a celebration day of the handover today, so I know you've got sort of public holiday, so thank you for joining us. So question then for the Ramboll team, this is from Sri Lanka. When you complete a project, are the BIM models passed on to the clients? And importantly, for us developing those skill sets, is training provided so we can use those systems for FM in the future and management of buildings?
I know in the UK we've developed something called soft landings. So that is when there's continued consultant input after the design is completed. Traditionally, the design would be completed, the consultant would not be involved at all. So in the UK, the government have mandated soft landings on all government projects. So that means continued involvement of the consultants after the design period to make sure the design works as intended and to train up the facilities management team. Regarding the BIM model, dare I say digital twin, we will provide the BIM model for the use of the facilities management, and within that BIM model, if we do it correctly, should be every single component. So in a building services term, every AHU, size, flow rate, manufacturer, every grill, diffuser, flow rates, pressure drop. So the simple answer is in the UK, yes. Globally, I'm not so sure.
I think it's probably worth saying there was a discussion early on about the client's understanding of EIRs and their understanding of BIM, and I think we're still on quite an early journey of that, of maybe clients understanding what the value is and what the benefits are and what they could do with that information. There's certainly smaller projects that we're doing, 3D digital environments collaboratively, all the things that we've spoken about that BIM is there for, but we're still delivering them in a more traditional way because that's what the clients are expecting. So there's definitely an education to be done there, and it's definitely something that we want to continue to do and do more of, but it's a slow process, I think.
There was a second question from Sri Lanka as well. Let's ask it. So what does it all cost as an on-cost to the project? That's a nice question.
That is a good question. So I think early on in BIM and digital engineering, it was seen as an extra cost. It was an extra process. Why are we paying for this when you could do it just as well on 2D, for example? I think being able to bring the risk forward and do more detailed design, coordination, That saves cost in the project. Being able to deliver projects quicker, that saves cost in a project. But internally for consultants as well, if we can deliver that project more effectively and efficiently, then we can offer that to the client at a more competitive cost, for example, if we have those processes in place. So early on, yes, it was an extra cost. I think it's becoming business as usual, like you mentioned now for BIM. So I don't think it is an extra cost at the moment, really.
No, I just agree with that, and I think it's a cost saving.
Yeah.
In the long run.
Cost saving, that's something else, yeah.
Don't hold us to that, but yes.
No, I think long term it's a cost saving, but I think you're right in terms of the clients understanding the value proposition of it down the road.
Yeah.
Because not all do, and my argument with that is that when we started it all off 12 years ago, we spent a lot of time bestowing the value and talking about the value in the design and construction phase, and I don't think arguably there was enough effort at that point, because it was all to do with the government knew what the value was, but I don't think there was enough effort put in at that point to talk about what the value was to the client wider, so they didn't really understand it. So that's why we're going through, dead right, that education phase of trying to educate clients as to what the value is to them later on down the line. We've probably still got a long way to go on that, as you say, absolutely, quite agree.
Thank you. The closing question, there was a lot more, but I've chose some of what I thought was really good. This is from the UK, and this is for someone on the nuclear plant, and thank you for joining us. So, real good question to all the panel. Where do we stand in respect of all this technology and interoperability between systems, particularly where there is historic data on projects which we would wish to update on modern cloud systems? And I haven't got an answer for that, so I'm going to hand that over to you guys.
You guys want to?
After you.
I have a view on that. Look, God, what was the question?
Interoperability.
Okay, let's deal with that one first.
Yeah.
So, interoperability, massive problem for the industry, still. Industry foundation classes, utopian solution. We've been talking about that since 1996, when they first developed it. We still haven't fixed it. So what are we now? Nearly 30 years on, and we still haven't fixed that. Right, so we're all getting there, and you guys probably deal with IFCs day in, day out. But they don't work 100% of the time, I would argue. So we've still got a massive issue with interoperability. De facto standards, there's Autodesk who are a de facto standard supplier to the industry, but there's so many other tools coming on stream and niche that we have got a massive issue with interoperability still. And I don't see that going away anytime soon for us. So that's my little bit on interoperability. What was the other bit on it? I can't remember.
The second bit I think that we're trying to indirectly ask was around the security element of all this, with it being on cloud, with it being on systems that anyone could access or hack into, probably with that nuclear protocol in mind.
Yeah, with that in mind, and I've worked on some of those nuclear projects as well, and I think one of the things that we had was that the servers had to be in the UK borders for the data, so we couldn't use the likes of BIM 360 or because we couldn't actually say with any definition where that data was, so that led us into a different path for it. There are security documents. Moses mentioned the standards, so there is Part 5 document, which is all around security of built assets. And because we're creating digital assets, and there's a lot of people who'd like to get their hands on that, whether it be prisons, nuclear plants, underground, whatever it is, you could do a lot of damage. And I've got a couple of stories around that. So there are protocols with it. I think some of the nuclear stuff we are challenged, and it's meaning that we're not potentially using some of those cloud storage systems as we are on other projects, because we have to maintain it in the UK boundary and the UK border. Again, I think that's something that we're not quite there. The fact that the standard for security was Part 5 tells you that there were 4 other things before it, and then all of a sudden we went, oh God, security. We've got to think about that one as well. I think that even the numbering of it tells you that it was a thought after or downstream of the event. So work in progress, and still a challenge for it. You know, how many times we did it this morning, right? We still email stuff to ourselves.
Yeah.
People are still emailing BIM files or sending them on, say, WeTransfer or things. You know, the fact that they could go anywhere. They could be hacked anywhere. So we've still got a lot of education within the industry about cyber security that we've got to do. And it's quite lucky that we host the UK Cyber Security Centre here in Wolves as well, because that means we've got a bit of a head start on some of that.
Anything to add, James?
Okay, so thank you for those questions, and I do understand and I know the work that is taking place down at the nuclear plant. So I do know what my views are on that question and answer, but I won't share it on this discussion for sure. So thank you very much for your questions online. So let's go to the audience in the room, if we may. Any questions? And I think, John, had you got a question to start us off with?
Yeah, coming back to the price of BIM and the consultancy fee, we know there's a fee, but is that 0.5%, 1%, 2% of the overall project value?
So Mr. Reynolds in the audience is trying to push the gentleman. I'm going to explain it just in case I don't hear you, John. So they're suggesting, what is that add-on cost, which I think was a question from Sri Lanka. So is it 0.5, 0.25, 0.1? So gents, come on, you have to go and answer. You can't hide. Give it another go.
I think even if there was a flat number that I could give you, I probably wouldn't share it today.
But there's an initial cost which reaps the benefit of the saving in the redesign, etc. And I came up with, it's probably an advanced form of value engineering.
I think you could certainly see it that way. There's certainly a lot of talking about moving the risk upstream, that kind of elements, and I'd completely agree. But there's also a cost saving for doing that design work. I think we've mentioned the tools that you can use. If an architect comes to us now and gives us some 2D information, we kind of roll our eyes and go, oh, this is going to be a difficult project now because we've got to use those older tools. So I think the more that we do 3D, the more it's business as usual, the more the costs are going to potentially come down, or maybe not come down, but we're going to be able to do more with those costs, do more of that early stage analysis, get more value, like you say, more value engineering right from those early stages. So.
And of course, as you already mentioned, one of the benefits is in working practice, 10, 15, 20 years time, you want to make alterations, then you've got the BIM drawings, all the information, and that's a halfway point from remeasuring the project to start.
Absolutely. So long as the client knows that they've got that information and they've kept it up to date, and et cetera, et cetera. But yeah, absolutely.
There was, John, going back early days, back a few years, there was actually a very elaborate calculation about return on investment of implementing BIM. I don't think it's valid anymore, by the by. But there was one, I can't remember where it was. If you search for it, you'll probably find it online. It's about that long. But some people had actually done an ROI calc of BIM implementation, and it went through the time, the software implemented, the technology, the training, everything of it. And a lot of people were using that to then take it back to like a fee. I think it's gone now.
But I think, John, for the value of cost thing is more on long term than short term. It's more on the long term, particularly if the client wants to, have that asset model for operation and maintenance. I think that is where, if it's just, I know there's cost saving within, in design and construction phase. However, the main value add is more on the maintenance and operational phase. For example, that Alaska project that I showed there, they used to spend over 15 billion a year for maintenance because of poorly managed facility management process that they engaged. But when they had the asset model, it may have cost them more initially to get all those, but they were able to reduce that drastically.
Okay, thank you. Good question, good answers there. I don't think you got the answer you were quite looking for, but we're moving into that space for sure. Any other questions in the audience? No? Sure? Okay, no questions in the audience then. Let me just reflect on one more question then. That was then, I was trying to sort of control the questions. So the question was asked around some of the work of reordering materials, so it's what you were referring to. So if it was a grill or event, which I think you made reference to, is there then a link to the manufacturer of that link and grill, or is it just the product? So is there a way? And the reason I think that question was asked is a bit of work myself and David have done with some museums. So if you use a Black Country Living Museum at the moment, to get access to assets, i.e. whether it was coupons or whether it's cigarette packets and the original packets, used to be a real nightmare. But through using platforms like eBay and other platforms that are out there, they can now better source those materials, and particular for buildings if they want a particular chimney pot or anything like that. So that's been really useful. So do you think BIM is going to be able to give you the exact details, or is it that the grill is such size and that's what's required to be replaced?
I think it could give the exact details, but generally the industry moves that quickly. That same product might not be available in 5 years. So I think it could give you the exact details, but 9 times out of 10 it will give you the performance. So size, pressure drop for a grill, and flow rate.
I think if the employee put that in their EIRs from early stages and that was a requirement, then we presumably would put that information in. But I think it depends on what stage of the design you're at. So we generally sort of do REBA stage up to sort of REBA stage 4. We wouldn't necessarily always specify the exact make, model of that grill, but we'd make sure that it had the relevant information to us about, like we say, the pressure drop, the volume, that kind of thing. But for the data, the operational model, you would add that information in so that it could be reordered. That kind of thing already sits in your operation and maintenance manuals in folders in the back office somewhere. So if that's now in a model, then that's accessible.
Perfect. Okay, so
Can I just ask some?
Yes, of course.
The Rambo software you presented, how does it help CFD analysis? Does it automate CFD analysis, or do you have to manually input things to get the figures out? I mean, computational fluid dynamics. It does it, right?
Yeah. The RAM view is almost a host for multiple add-ins. So you can load in the Revit models, you can load in the point cloud survey, and you can load in the CFD analysis, which has been done on another piece of software, be that Rhino with a Grasshopper plugin, be that IES, be that TAS. So it's just, a lot of the time you'll get a CFD analysis, it'll come in a report.
2D.
It's 2D, it's really long, it's hard to visualise. Whereas the RAM view, you can put a VR headset on and you can see where the issues are in real life, and it's really powerful for the client, because 9 times out of 10 the client is not technical, they're just paying you to do the service and hoping you know what you do, hoping you know what you're doing. So we can say to a client who's not educated in the built environment that you've got an issue with temperature in this corner, we will aim to combat that in that corner. Do you have anything to add?
I think we talked about BIM a lot and the standardisation, but I think it's important to note that standardisation and that framework that's there has allowed us to develop these tools. And now those tools are developed, we can communicate that information much more effectively. So RamView is an example with the CFD loaded in. You can just send that link to the client and they can go around and flick through and have a look through, and they can view that information the way they want to view it. The olden days of an analog report in 2D and you describe all of those different areas in paragraphs of text, the client might not understand that or read it. I think it's unlocked a lot of better methods for us to communicate that design as well, which is what RAM View is really for, I think.
Perfect. Okay.
There was just one more question.
Yeah, sorry, one more question. Yeah.
Just one question on that. So I found it really interesting because I actually worked for a contractor recently, a very big contractor, and they were using BIM or CAD models to identify the service runs in their building, so it's going to be a new build. They put a lot of effort into that CAD file. It was really detailed, and basically the idea was they were going to send that information to the manufacturer to manufacture the steel beams to prevent clashes. So they put all that together, sent it to the manufacturer. The manufacturer didn't pay enough attention to the CAD file, and then when they get to the construction stages, those clashes are still occurring because the beams haven't been manufactured correctly. So that's obviously a problem. Do you guys have that problem when you produce these files?
So let me just repeat that question if I may, and I'll try and paraphrase it. So we've got a question from the audience there that is saying, work for a contractor. They spent a lot of time in the production of drawings in particular to trying to avoid clash of services. So they produced the files for the project. They've sent them across to the manufacturer of the steelwork within the project so they could analyse that and avoid sort of clashes and provide apertures for the services. However, it would appear they didn't pay the attention they should have done, and they've still ended up with all those clashes, which obviously is a real disappointment. And I think the question was, is this more commonplace, or how can we prevent it happening a little bit more?
So these existing services then? Or is this a new build project?
It's a brand new build project. The services were going to be installed at a later date, I believe.
So I think it's an opportunity for 3D environment is that you can, it's an extra level of detail that you've got to add in, but what that does is moves that risk of clashes forward and they can be solved on a computer. And I think, again, automating that data, collaborating that data with the structural engineer, with the manufacturer even of those elements, they can visualize, they can understand where that is, and they can see in 3D, they can see the clashes. You can automate clash detection to find those clashes and resolve them. So I think there's definitely an opportunity with the 3D common data environment that you can design those clashes out. I think the 2D is more onerous, like you say. It's going to be really difficult to model those accurately and to then produce drawings. You've got to produce those drawings in 2D, PDFs presumably that you've sent then to, or CAD models that you've then sent to the structural engineer.
This was actually a really advanced 3D model.
Okay.
I think manufacturer just didn't pay attention to it.
Sorry, go on.
Yeah, I think a lot of the issues are that as an industry, we're not all at the same level when it comes to BIM. Some people are quite advanced, some people aren't that advanced. Traditionally, the contractor sorts out a lot of things on site, so clashes, so a lot will be left to the contractor, and some people, unfortunately, are still in that mindset. So that may be where that particular issue came from. And we do encounter it. We can have a model which is clash-free, but when it gets to site, it just takes one person to take their eye off the ball, and you've got a problem.
Let me cover that because I've been working for the last couple of years with a specialist subby who does the ventilation. So they'll take that design, do the fabrication work for it, make it up in the shop, and take it down and install it. And we had almost like the opposite problem, I guess, where we got the model, we got the structural model in, and we were sort of, we were at stage 4. Coming into that stage 4, stage 5. The issue we got is when it got to site, what they're saying, it changed, and the models had been updated after it. It's almost like a site change. The model had been updated, but it was never issued to us. So we'd designed detailed design. We'd fabricated based on that, and it'd gone on the truck, and it was let's say a prominent project that's just opened in London, underground, and it was only when we got down there we realised that that's not going to work. So that was, that was almost not a digital technology problem. That was the human data not being issued problem, which is the time-old problem of working off the wrong revision drawings. It's the up-to-date version of that. That's what we had. Similarly, where it did work for us, and this is where we did some of the scanning work, we fabricated a big piece of ductwork, or we were in the process of doing it, and one of the lads went down on site and sort of scanned it, and we realised that where they'd put one of the walls up, the blockwork up for it, and actually we couldn't physically manoeuvre that piece of ductwork around. So it would fit, and that was all right, but we couldn't get it to where it needed to go, because it was almost like we were doing a vehicle track and we were able to say we can't get it in, we can't physically move it in. So we've got to take that wall back down again, get it in, and then rebuild it. So on the flip side, that helped us solve a problem before we actually got to site. But I think your first question is, we've still got that issue, and you think quite right, people being at different levels. We've still got that issue as well of data not being issued, the right data not being issued. Time-old problem. Great tools, but still a human involved.
Okay, thank you for that, and good question for sure. And it's the old adage, about communication, and we haven't cracked that yet. That's where most of the mistakes are made, and that's a further example. Right, so we'll bring this to a close. Can I first of all thank everyone for attending online. As I said to you, we'll be very shortly, next few days, putting this back out on QSI YouTube link. So look out for that, and we'll get some links and announcements to that. We look forward to you joining us on the first Thursday club as well, where we'll be, Simon will be joining us and talking about sort of developments in the sector and the market position and what's happening in the marketplace, which is really very useful at this time. And once of all, can I also thank our amazing speakers today, and in the usual way, for those in the audience, show our appreciation. Thank you very much indeed. Thank you very much for joining us, and keep safe, and wherever you are and whatever your time zone is, look after yourself, stay safe, and keep in touch with Suzanne and Quantsurveying International, trying to interact and develop greater knowledge exchange. Thank you very much.